Before Charles Darwin set foot on the Galapagos Islands in 1835, the living world was understood through the lens of divine creation, a static tapestry woven by an omnipotent hand at the beginning of time, with each creature fixed in its appointed role and form forever. Yet as Darwin observed the subtle variations among finch beaks across different islands, the slight differences in tortoise shells from one locale to another, and the curious way that organisms seemed perfectly adapted to their specific environments, a radical possibility began to form in his mind, one that would eventually overturn centuries of certainty about the nature of life itself. The mechanism he discovered was deceptively simple. Within any population of living things, individuals naturally vary in their traits and characteristics, and when resources become scarce or conditions grow harsh, those organisms whose random variations happen to suit them better to their environment survive more often and produce more offspring, passing those advantageous traits to their descendants, while less suited variations gradually disappear from the population over countless generations. This process, repeated across millions of years and billions of organisms, could explain not only the adaptation of creatures to their habitats, but the very origin of species themselves, the branching tree of life that connects all living things through common ancestors stretching back through deep time. What remains remarkable is how thoroughly this mechanism persists as the foundational explanation for biological diversity. Despite the visceral human intuition that complexity must be designed, that purpose must be intentional, that the intricate eye or the soaring wing could not possibly emerge from blind, undirected processes alone. In 1952, a British scientist named Rosalind Franklin was working in a London laboratory, carefully positioning microscopic fibers of deoxyribonucleic acid under an X-ray diffraction apparatus, a delicate process that required extraordinary precision and patience, her meticulous hands adjusting equipment that would eventually produce one of the most consequential photographs in the history of science, a black and white image that would later become known as Photo 51. Revealing for the first time the shadowy outlines of a spiral structure hidden within the very molecules that make up all living things. Franklin's work, conducted in the basement laboratory of King's College London, involved bombarding DNA crystals with X-rays and carefully measuring how the radiation scattered and bounced back, creating diffraction patterns that could be interpreted to reveal the three-dimensional architecture of the molecule itself. And though she did not initially realize the profound significance of what her equipment was showing her, she was documenting the physical evidence of life's instruction manual. The discovery of the DNA double helix structure represented a fundamental shift in how humanity understood itself, moving beyond abstract theories about inheritance and heredity into a concrete, measurable, visible reality, a tangible molecule that could be seen and studied and understood through the lens of chemistry and physics. What made this discovery psychologically revolutionary was not merely that it showed us what genetic material looked like, but that it revealed an elegant simplicity underlying the incomprehensible complexity of all biological life, a mechanism so logically perfect that it seemed almost designed. Two complementary strands wound around each other in a spiral pattern, where each base on one strand fit precisely with its partner on the other, creating a self-replicating code that could be copied with remarkable fidelity across generations. For nearly 2,000 years, humanity operated under a fundamental misunderstanding of its place in the cosmos, one so deeply embedded in the fabric of civilization that questioning it seemed not merely foolish but heretical. And this misunderstanding was that the Earth occupied the center of the universe, with the sun, moon, planets, and stars all orbiting around it in perfect celestial spheres. A model known as geocentrism that seemed intuitively obvious to anyone who simply looked up at the sky and observed the apparent motion of the sun rising in the east and setting in the west, a motion that appeared to confirm with absolute certainty that our world was stationary and supreme. The psychological mechanism underlying this conviction was extraordinarily powerful because it aligned with direct sensory experience. Every human who ever lived could feel the solid ground beneath their feet and could observe the heavens moving overhead, and from this perspective, the geocentric model made perfect logical sense as an explanation of observable phenomena, reinforced further by ancient philosophers like Aristotle and later codified into religious doctrine by the Church, which found in this earth-centered universe a reflection of divine hierarchy with humanity at the center of God's creation. Yet beginning in the 16th century, astronomers like Nicholas Copernicus began proposing a radical alternative, suggesting that the Sun, not the Earth, occupied the center of the solar system, and that our planet was merely one of several celestial bodies orbiting this central star, a proposition so counterintuitive and so threatening to established authority that it required centuries of accumulated observational evidence, from Galileo's telescopic discoveries to Newton's laws of motion, before it achieved acceptance in the scientific community and eventually in the broader culture. In the early 20th century, a Swiss-born physicist named Albert Einstein proposed a radical reconceptualization of space and time that fundamentally altered humanity's understanding of the universe itself, suggesting that gravity was not a force pulling objects together as Newton had theorized, but rather a curvature of spacetime caused by the presence of massive objects, and that time itself could slow down or speed up depending on gravitational fields and velocity relative to light. The real-life situation emerged from careful observations and mathematical reasoning about how light behaves around massive celestial bodies and how time flows differently in different gravitational conditions, leading Einstein to conclude that massive objects actually bend the fabric of spacetime around them, much like how a heavy ball placed on a stretched rubber sheet creates a depression that causes nearby objects to roll toward it. The psychological and conceptual mechanism behind this discovery involved a profound shift in how we think about the nature of reality itself, moving away from the intuitive notion that space and time are fixed, absolute, and unchanging containers in which events occur, and instead embracing the counterintuitive idea that spacetime is a dynamic, flexible entity that curves and warps in response to matter and energy, fundamentally linking space, time, and gravity into one unified framework. This theory explains phenomena that Newton's gravity could not, such as the precession of Mercury's orbit, the bending of starlight around the Sun, and the existence of black holes. Yet what remains remarkable is how thoroughly this genuinely alien concept has been woven into our modern understanding, how we have absorbed this mind-bending reality into our collective consciousness and educational systems without experiencing ongoing cognitive dissonance. Moving forward as if the universe behaving in this way was somehow always expected or obvious, when in truth it represents one of humanity's most profound intellectual achievements and most counterintuitive windows into how reality actually functions at its deepest levels. At the heart of reality itself lies a realm so fundamentally strange that it defies every intuition we have developed through living in the everyday world, a place where particles exist in multiple states simultaneously until the moment we observe them, where an electron can tunnel through a barrier that should be impossible to cross, and where two particles separated by vast distances can instantaneously affect one another in ways that seem to violate the very laws of space and time we thought were absolute and immutable. This is not metaphor or poetry, but rather the literal description of how the universe behaves at its smallest scales, a framework of physics that has been tested countless times and verified to extraordinary precision, yet remains so counterintuitive that even the physicists who helped develop it expressed profound discomfort with its implications. The psychological mechanism that allows us to accept this strangeness operates through a gradual normalization process, whereby we learn to separate our everyday experience from subatomic reality, treating quantum mechanics as a specialized tool for calculation rather than a genuine description of what exists. Much like how we can intellectually understand that we are hurtling through space on a spinning globe, while our sensory experience insists we are standing still. We have been taught to trust the mathematics of quantum mechanics because it works with stunning accuracy, predicting experimental outcomes to many decimal places. Yet this success paradoxically deepens the mystery rather than resolving it, because the mathematics describes something that seems fundamentally incompatible with our understanding of objective reality. Imagine standing at the absolute edge of existence itself, peering backward through 13.8 billion years of cosmic history to a moment so incomprehensibly distant that it exists almost as a mathematical concept rather than a physical event. And at that threshold, you encounter the Big Bang, the singular moment from which our entire universe and everything within it emerged from an infinitely dense point of pure energy. This discovery fundamentally reshaped our understanding of reality by proposing that the universe itself had a beginning, that space and time did not exist as eternal fixtures, but rather burst into being in a cataclysmic explosion of creation that continues to expand outward even now, with galaxies racing away from one another at velocities that increase with distance. The mechanism behind this realization emerged gradually through the 20th century as scientists observed that distant galaxies were moving away from us. And when they traced this pattern backward mathematically, they found that all matter and energy must have originated from an infinitely hot and infinitely dense singularity, a state so extreme that our physics simply breaks down and cannot describe what occurred at that precise moment. What makes the Big Bang so profoundly mind-altering is that it suggests time itself began with the explosion, that asking what came before the Big Bang is fundamentally meaningless because before implies time, and time did not exist prior to the universe's creation, forcing us to confront the unsettling reality that causality itself may have limits. For centuries, humanity gazed upward at the night sky and assumed the cosmos was static, eternal, and unchanging, a perfect crystalline sphere of stars fixed in their positions relative to one another, bound together in an infinite dance of gravity that had persisted since the beginning of time itself. This assumption was so fundamental to our understanding of reality that it went largely unquestioned, embedded in the very fabric of our philosophical and scientific worldview as deeply as the earth beneath our feet. Then, in the 1920s, the astronomer Edwin Hubble made observations through the Mount Wilson Observatory that would fundamentally fracture this assumption, revealing that the universe was not static at all, but rather actively expanding in all directions simultaneously, as if the cosmos itself were an enormous balloon being inflated at an incomprehensibly vast scale. Through careful measurement of the light from distant galaxies, Hubble discovered that nearly all of them were moving away from us, and perhaps more shockingly, the farther away they were, the faster they were receding, suggesting that space itself was stretching, pulling galaxies apart like raisins in rising dough, expanding into territories that did not exist before. The psychological mechanism that allowed us to accept this revelation, despite its radical departure from intuition, lies in our remarkable capacity for cognitive compartmentalization and gradual normalization of the extraordinary. For once this expansion was measured and mathematically formalized, we simply incorporated it into our accepted model of reality and moved forward. For most of human history, the vast majority of people believed that disease arose from miasma, a kind of noxious air or vaporous corruption that hung over cities and swamps and somehow entered the body to cause illness, or alternatively that imbalances in the four humors, blood, phlegm, yellow bile, and black bile, were responsible for virtually every ailment from plague to fever to madness, and doctors would therefore treat patients by bloodletting, purging, and applying leeches in an attempt to restore humoral equilibrium, and these practices persisted for over 2,000 years across virtually every civilization on Earth despite producing no meaningful improvement in survival rates and often accelerating death itself. The invisible world of bacteria and viruses, the actual culprits behind these diseases, remained completely unknown because the microscope had not yet been invented, and so humanity stumbled through centuries of darkness, burying millions of people each year while confidently applying treatments based on philosophical speculation rather than observable reality. Then in the late 1800s, scientists like Louis Pasteur and Robert Koch began to peer through magnifying lenses and discover that tiny living organisms existed everywhere, that these microorganisms could be cultured and studied, and that specific germs caused specific diseases in a direct and reproducible manner, fundamentally overturning thousands of years of medical tradition in the span of mere decades. The psychological mechanism that allowed miasma theory to persist so long was the human tendency to construct elaborate, coherent explanations for mysterious phenomena rather than simply accept ignorance, and to become so invested in those explanations that contradictory evidence seems somehow less credible than the comfortable framework already in place, a phenomenon we might recognize as cognitive resistance to paradigm shifts. For most of human history, we stood upon the earth and assumed it was solid, permanent, and fundamentally unchanging in its basic structure, a great unmoving stage upon which all of civilization's dramas would unfold across the ages without alteration or disruption to the ground beneath our feet. Yet beneath the thin crust that supports our cities and mountains and oceans lies an extraordinary truth that fundamentally reshapes our understanding of planetary mechanics. The very surface we walk on is broken into massive, slowly drifting pieces that collide, separate, and slide past one another in an endless choreography of geological motion spanning millions of years. These tectonic plates, some as large as entire continents, move at rates comparable to the growth of human fingernails, Yet over geological timescales they rearrange the world entirely, creating new mountains through collision, generating earthquakes along their boundaries, spawning volcanic eruptions where magma rises between separating plates, and gradually redistributing the continents across the globe in patterns that would seem impossible if we compressed time to human perception. The mechanism driving this constant motion originates from deep within the Earth's interior, where radioactive decay generates tremendous heat in the mantle, creating convection currents that rise and fall beneath the rigid crust like boiling water beneath a floating sheet, pulling and pushing the plates in directions determined by these subterranean forces utterly invisible to us at the surface. What remains psychologically remarkable is how recently humanity understood this fundamental reality, for it was not until the 1960s that the theory of plate tectonics achieved scientific consensus, despite the obvious visual evidence surrounding us. The way continents fit together like puzzle pieces, the distribution of earthquakes and volcanoes along predictable lines, the age patterns of ocean floor spreading outward from underwater ridges. Imagine standing on a beach, holding a single grain of sand between your fingers, and being told that this tiny particle represents 1 year of human civilization, while the entire beach stretching endlessly in both directions represents the age of the Earth, and beyond that beach, across an entire continent of sand, lies the age of the universe itself. This is the fundamental challenge of understanding deep time, a concept that fundamentally rewires how we perceive our own existence and our place in the cosmos. Deep time refers to the vast expanse of geological and cosmic history, measured not in centuries or millennia, but in millions and billions of years, a scale so incomprehensibly large that the entire recorded history of humanity becomes virtually imperceptible when placed against it. The Earth has existed for approximately 4.5 billion years, yet humans have only walked upright for roughly 3 million years, and modern civilization has existed for merely the last few thousand years, meaning that for 99.9% of our planet's existence, we did not exist at all. What makes deep time so psychologically devastating is that our brains evolved to understand timescales measured in seasons and decades, not eons and epochs. So when we attempt to truly grasp that the Rocky Mountains will be worn completely flat by erosion, or that the sun will eventually expand and consume the Earth, these concepts remain intellectually known but emotionally abstract. We can recite these numbers and facts with perfect accuracy, yet something in our consciousness resists fully internalizing what they mean, perhaps because accepting the true scale of deep time forces us to confront our own cosmic insignificance, the brevity of our individual lives, and the temporary nature of everything we build and cherish. Imagine a place in the universe so dense, so incomprehensibly massive, that it warps the fabric of space and time itself into a region from which nothing, not even light traveling at the fastest speed known to physics, can ever escape once it crosses a particular threshold called the event horizon. This is the black hole, a cosmic object so extreme that it challenges our ability to visualize reality itself. Yet it exists not as theoretical speculation, but as an observable phenomenon that astronomers have detected throughout the universe, studying them with telescopes and gravitational wave detectors that reveal their presence by the violent effects they have on surrounding matter and the very geometry of spacetime around them. When massive stars, those giants that burn millions of times brighter than our sun, finally exhaust their nuclear fuel after millions of years of burning, they collapse inward with such tremendous force that their entire mass compresses into an impossibly small space, creating a density so extreme that it fundamentally breaks down our conventional understanding of physics and creates a singularity, a point of infinite density surrounded by the event horizon, that invisible boundary of no return. What makes this discovery so profoundly disorienting is that black holes exist at the intersection of two great theories that typically conflict with each other. Einstein's general relativity, which describes gravity and the behavior of massive objects, and quantum mechanics, which governs the smallest scales of reality, and yet black holes demand that both theories somehow apply simultaneously, creating a paradox that physicists still grapple with today. Imagine standing in a vast, empty universe where nothing moves faster than an absolute cosmic speed limit, a boundary so fundamental that it governs everything from the behavior of electrons to the expansion of galaxies themselves. And this limit is the speed of light, traveling at approximately 186,000 miles per second through the vacuum of space. For centuries, scientists assumed light traveled instantaneously, that it simply appeared everywhere at once. But in the 1700s, Danish astronomer Ole Romer observed the moons of Jupiter and noticed something peculiar. Their orbits seemed to shift depending on Earth's position relative to Jupiter, taking longer to complete their cycles when Earth moved away and shorter when Earth drew closer, a phenomenon that could only be explained if light took measurable time to travel across the vast distances of space. This discovery fundamentally shattered the intuitive notion that light was instantaneous, revealing instead that even the fastest known phenomenon in the universe has a finite, measurable velocity. What makes this discovery psychologically profound is that it establishes a cosmic speed limit that cannot be exceeded by any massive object, energy, or information. A boundary so absolute that Einstein's theory of relativity shows us that as objects approach light speed, time itself dilates, space contracts, and mass increases infinitely, meaning nothing with mass can ever actually reach this velocity, only asymptotically approach it. The mind struggles to accept this constraint because our evolutionary experience taught us that faster movement simply requires more energy. Yet the universe imposes a hard ceiling where additional energy cannot make anything go faster once it approaches light speed, an inversion of our everyday understanding of acceleration. Every single moment of your existence, you are being pulled downward by an invisible force that you cannot see, touch, or escape, a force so omnipresent and so constant that you have likely never spent more than a few seconds consciously thinking about it, and yet this force shapes the very architecture of reality itself. Gravity is the phenomenon by which all matter with mass attracts every other piece of matter in the universe, and it operates according to a principle so elegantly simple that it seems almost impossible such a fundamental law could govern everything from the trajectory of falling raindrops to the orbital mechanics of distant galaxies. When you stand on the ground, you experience approximately 9.8 meters per second squared of acceleration pushing you downward, a measurement so consistent that we have built our entire understanding of physics around it. And yet gravity remains the weakest of all the fundamental forces, trillions upon trillions of times weaker than electromagnetism or nuclear forces, which makes it all the more bewildering that it dominates the large-scale structure of the cosmos. What makes gravity truly mind-shattering is that for centuries we knew it worked, we could measure it, we could predict it with extraordinary accuracy, and yet we had absolutely no idea why it worked at all, no mechanism, no explanation for the cause of this universal attraction. Isaac Newton described gravity mathematically without explaining its nature, and later Albert Einstein reimagined gravity not as a force at all, but as the curvature of space and time itself, a concept so counterintuitive that it took decades for physicists to fully comprehend it. Even today, despite our sophisticated theories, gravity remains partially mysterious, operating according to rules that seem to contradict quantum mechanics, the other pillar of modern physics, suggesting that our understanding is still incomplete. For thousands of years, humanity gazed upon the material world and perceived it as fundamentally solid and continuous, a seamless fabric of matter that could be divided only so far before reaching some ultimate, indivisible foundation. The ancient Greek philosopher Democritus proposed around 440 BC that all matter consists of tiny, eternal particles called atomos, meaning uncuttable, yet this remained purely philosophical speculation without any empirical foundation whatsoever. It was not until the early 19th century that John Dalton, an English schoolteacher and meteorologist, began conducting careful experiments with gases and chemical reactions, discovering mathematical patterns suggesting that matter indeed consisted of discrete particles combining in fixed proportions, thus breathing scientific credibility into an idea that had languished in the realm of pure conjecture for millennia. What Dalton and subsequent scientists discovered was genuinely astonishing. The material world, everything we touch and see and experience as solid, is actually composed almost entirely of empty space, with tiny nuclei surrounded by clouds of electrons existing in probability distributions rather than fixed orbits. The atom itself is so minuscule that a single grain of salt contains approximately 10 to the 18th power of atoms, a number so vast it exceeds the total number of stars visible to the naked eye in the entire night sky. The psychological mechanism that makes this discovery so profoundly disorienting is our evolutionary mismatch with scales of reality beyond our immediate perception. Our brains evolved to navigate a middle realm of moderate distances and moderate sizes, and the atomic scale exists so far below our sensory threshold that it feels almost supernatural, challenging our basic intuition that what is real must be perceptible. In the early 1960s, two Bell telephone scientists named Arno Penzias and Robert Wilson were working with a large horn antenna in New Jersey, trying to detect radio signals from space, when they noticed a persistent and inexplicable noise coming from every direction in the sky. A faint electromagnetic hum that seemed to originate from nowhere and everywhere simultaneously. A cosmic whisper that refused to be silenced, no matter how carefully they cleaned their equipment or adjusted their instruments. What they had stumbled upon, entirely by accident, was the afterglow of the Big Bang itself, the oldest light in the universe, radiation that had been traveling through the cosmos for nearly 13.8 billion years, cooled down by the expansion of space into a faint microwave glow that permeates everything, a uniform bath of photons that bathes our planet and all of existence in the faint warmth of creation's first moments. The psychological power of this discovery lies in its profound reversal of our intuitive understanding of absence and presence. We expect the universe to be mostly empty, mostly dark, yet this radiation reveals that we are literally swimming through the light of the Big Bang, that emptiness itself is filled with something ancient and all-pervading, that nowhere in the universe can escape this signature of its own birth. What makes the cosmic microwave background particularly mind-shattering is how it transformed theoretical physics into observational fact, taking equations and predictions and converting them into measurable reality, proving that the universe had indeed begun from an extraordinarily hot, dense state and then expanded outward, carrying this primordial light with it as a kind of cosmic fossil record. In the closing years of the 19th century, scientists were conducting experiments with mysterious rays that seemed to emanate from certain elements, particularly uranium, and they noticed something profoundly unsettling. Matter itself was unstable and breaking apart at the atomic level, releasing energy in the process, a phenomenon that would come to be called radioactivity. Marie Curie and Pierre Curie worked tirelessly with pitchblende ore, isolating new radioactive elements like polonium and radium, handling materials with bare hands that we now know were slowly poisoning them. Yet they persisted because the scientific mystery was so compelling that it overrode any sense of danger or self-preservation. The discovery revealed that atoms were not the indivisible particles that ancient philosophers had imagined, but rather complex structures containing enormous amounts of stored energy that could be released through radioactive decay, transforming one element into another entirely, a process that occurs spontaneously and without any external stimulus. What made radioactivity conceptually revolutionary was that it demonstrated matter was actively transforming itself at all times, that the solid objects around us were undergoing constant invisible transmutation, and that energy was literally radiating outward from these decaying atoms in the form of alpha particles, beta particles, and gamma rays. Yet despite understanding the mechanism of radioactive decay, despite knowing that certain isotopes emit dangerous radiation continuously, humanity has spent the subsequent century and a quarter normalizing our relationship with radioactive materials, using them in medicine, energy production, and weapons systems, while simultaneously fearing them deeply, a psychological duality that persists without resolution. Imagine standing in a chemistry classroom, where a single laminated poster on the wall contains the fundamental architecture of absolutely everything around you, organized into neat rows and columns with symbols, numbers, and colors that seem almost arbitrary at first glance. This is the periodic table of elements, a discovery so profound that it revealed the universe operates according to elegant mathematical and chemical principles that had remained hidden until the mid-19th century. Before Dmitri Mendeleev arranged the known elements in 1869, chemists had accumulated knowledge of approximately 60 distinct substances, yet they possessed no coherent framework for understanding why certain elements behaved similarly to one another, why some were reactive while others remained inert, or what invisible forces governed their interactions and combinations. Mendeleev's genius lay not merely in organizing what was known, but in predicting what remained unknown, leaving gaps in his table for undiscovered elements and even specifying their likely properties with remarkable accuracy, a prediction that was later confirmed when gallium, scandium, and germanium were isolated in subsequent decades. The psychological mechanism underlying this discovery reveals how the human mind searches for patterns within chaos, how we unconsciously organize information into hierarchies and relationships that expose deeper truths. Mendeleev recognized that when elements were arranged by atomic weight, a periodic recurrence of chemical properties emerged naturally, suggesting an underlying order written into the fabric of matter itself. What makes this discovery particularly remarkable is how completely it has become normalized within modern scientific understanding, so thoroughly integrated into education and practice that we rarely pause to contemplate its revolutionary implications. The periodic table transformed chemistry from a descriptive science, cataloging isolated curiosities, into a predictive science capable of understanding atomic structure and chemical bonding at fundamental levels. Imagine standing in a vast laboratory where invisible forces permeate every atom of existence, forces so fundamental that they hold the very matter of your body together, yet for most of human history, we remained entirely blind to their presence. The discovery of electromagnetism represents one of the most profound revelations about the nature of reality itself, emerging not from a single moment of insight, but rather from centuries of careful observation and mathematical synthesis. Beginning with ancient Greeks rubbing amber and watching it attract dust particles, continuing through the methodical experiments of scientists like Michael Faraday and William Gilbert, and culminating in James Clerk Maxwell's elegant equations that unified electricity and magnetism into a single coherent framework. What makes this discovery so mind-shattering is that electromagnetism turned out to be one of the four fundamental forces governing all existence, responsible not only for the bonds between atoms but for light itself, for the functioning of every electronic device that surrounds us, for the very mechanism by which our nervous systems transmit signals. The psychological impact of understanding electromagnetism stems from a profound shift in human perception. We suddenly realize that what we perceive as solid matter is actually mostly empty space held together by electromagnetic forces we cannot see or touch or feel directly, that the table before you is solid not because atoms are packed tightly, but because electromagnetic repulsion prevents their electron clouds from overlapping. Despite this knowledge fundamentally altering our understanding of physical reality, we have normalized electromagnetism to such an extent that we barely pause when we flip a light switch or charge our phones, accepting without wonder the countless technological manifestations of forces that would have seemed like pure magic to our ancestors. These invisible electromagnetic waves now carrying our voices and images across continents and through space itself. In the autumn of 1928, a Scottish bacteriologist named Alexander Fleming returned to his laboratory at St. Mary's Hospital in London after a 2-week vacation. And in that ordinary moment of routine inspection, he noticed something peculiar on one of his bacterial culture plates that would fundamentally alter the trajectory of human medicine and save countless millions of lives across the subsequent decades. The plate, which had been left on his workbench, had become contaminated with a mold, and around this fuzzy blue-green growth, the surrounding bacteria had completely dissolved and disappeared, leaving behind a clear halo of sterility that suggested something remarkable was occurring within that fungal organism. Fleming recognized immediately that this mold was producing some kind of substance capable of killing the very bacteria he had been studying. And though he published his findings in 1929, the scientific community largely dismissed his discovery as an interesting curiosity rather than a practical therapeutic tool. And it would take more than a decade of obscurity before the full significance of penicillin would be recognized and developed into the first true antibiotic. The psychological mechanism underlying penicillin's eventual triumph was rooted in humanity's age-old struggle against invisible microbial enemies that had plagued our species since the dawn of civilization, causing infections that turned minor wounds into death sentences and transforming childbirth, surgery, and everyday accidents into potentially fatal events. And when Fleming's observation finally gained traction during World War II, when wounded soldiers desperately needed protection against gangrenous infections, the scientific world mobilized around this fungal derivative with unprecedented urgency and resources. Consider the remarkable paradox at the heart of vaccination, a medical practice so counterintuitive that it took centuries for humanity to embrace it despite its profound effectiveness. The fundamental concept involves deliberately introducing a weakened or inactive form of a disease-causing pathogen into a healthy body, a practice that seems to violate every instinct of self-preservation and caution that evolution has instilled within us. When Edward Jenner first inoculated a boy named James Phipps with cowpox material in 1796, he was performing an act that most of his contemporaries found deeply troubling, even blasphemous, introducing disease into the body of a healthy child in hopes of preventing a far worse outcome. The mechanism underlying vaccination operates through an elegant exploitation of immunological memory, where the immune system encounters a harmless version of a pathogen and develops antibodies and cellular defenses that remain dormant, ready to mobilize with devastating speed and efficiency should the real threat ever appear. This priming of the immune system represents one of humanity's most elegant discoveries in medicine, yet the practice persists in a state of paradox, protected by scientific evidence and public health infrastructure, while simultaneously remaining subject to waves of public skepticism and resistance. We have normalized the injection of biological materials into our bodies based on statistical probabilities and epidemiological projections rather than immediate sensory evidence of benefit, an unusual act of faith in abstract scientific reasoning that contrasts sharply with our evolutionary preference for tangible, visible proof. Vaccination demonstrates how human civilization has learned to trust invisible forces and delayed gratification, embracing preventive logic that protects not just individuals but entire communities through the concept of herd immunity, where a sufficiently vaccinated population creates conditions in which disease cannot spread efficiently. Imagine standing in a laboratory in the late 1800s, watching scientists grapple with a mystery that would fundamentally reshape our understanding of matter itself. They were observing the mysterious rays that emerged when electricity passed through gases at low pressure, and they noticed something peculiar. These rays could be deflected by magnetic fields, suggesting they possessed both mass and charge. Through meticulous experimentation, particularly the work of Joseph John Thomson in 1897, scientists realized they had discovered something far smaller than the atom itself, a fundamental particle that would later be named the electron. What made this discovery so profoundly disorienting was not merely that smaller particles existed within atoms, but that these electrons behaved in ways that defied classical physics entirely, moving in ways that seemed to violate the very laws of motion that had governed our understanding of the physical world for centuries. The electron could not be easily pinned down. It existed in a cloud of probability rather than a fixed orbit, and its very act of observation seemed to change its behavior, introducing a fundamental uncertainty into the fabric of reality itself. Yet despite this conceptual vertigo, despite the fact that electrons operate according to quantum mechanical principles that contradict our everyday intuition about how objects should behave, we have entirely normalized their existence in our modern world. We use electron flow to power nearly every device we depend upon, from the phones in our pockets to the lights in our homes, treating these ghostly particles as though their strange, probabilistic nature is simply another mundane feature of existence, no more remarkable than the wind or rain. Imagine standing in a laboratory where the fundamental nature of reality itself seems to shift depending on how you observe it, a phenomenon that has puzzled physicists for over a century and continues to challenge our deepest assumptions about what exists and how existence operates. When scientists began studying light and matter at the quantum scale, they discovered something profoundly unsettling. Electrons and photons do not behave as either particles or waves, but rather exhibit properties of both simultaneously, and more mysteriously, they seem to switch between these behaviors based on whether anyone is watching them. In the famous double-slit experiment, particles are fired at a barrier with two openings, and when no measurement device is present, the particles behave like waves, passing through both slits at once and creating an interference pattern on the screen behind. Yet the moment scientists install a detector to determine which slit each particle actually goes through, the particles inexplicably begin behaving like classical bullets, going through one slit or the other. And the interference pattern vanishes entirely. This strange duality arises from the mathematical frameworks of quantum mechanics, which suggest that particles exist in a state of superposition, holding multiple potential states simultaneously, until observation forces them into a definite configuration, a concept that seems to place consciousness at the center of physical reality itself. The mechanism underlying this apparent observer effect likely stems from the very act of measurement requiring interaction with the system being measured. And at quantum scales where systems are so small and delicate, any measurement interaction fundamentally alters the state of what is being measured. In the early 20th century, a young German physicist named Werner Heisenberg sat down to wrestle with one of the most perplexing puzzles emerging from quantum mechanics, a realm where the very act of observation seemed to alter the nature of what was being observed, and he discovered something that would fundamentally challenge our most basic assumptions about the nature of reality itself. Heisenberg realized that there exists an irreducible limit to the precision with which certain pairs of physical properties can be simultaneously known, such as the position and momentum of a particle, meaning that the more accurately you measure where an electron is located, the less you can know about how fast it is moving, and vice versa, not because our instruments are imperfect or our methods are clumsy, but because this uncertainty is woven into the fabric of existence at the smallest scales. The mechanism behind this principle emerges from the wave nature of matter itself, for when you attempt to pinpoint a particle's exact location, you must use light with an extremely short wavelength, and such energetic photons inevitably transfer momentum to the particle, thereby disturbing its velocity, creating an unavoidable trade-off between knowledge of position and knowledge of momentum. What makes this discovery so philosophically unsettling is that it demonstrates the universe is fundamentally probabilistic rather than deterministic, that God does not merely play dice with the cosmos as Einstein famously objected, but that the dice themselves are the only reality we can ever access. And yet, despite the profound implications and despite the century of scrutiny that has followed, the uncertainty principle remains a cornerstone of quantum mechanics, accepted and normalized in physics laboratories around the world. In 1928, a British physicist named Paul Dirac was working through the mathematical equations of quantum mechanics when he noticed something deeply peculiar emerging from the theoretical structures themselves, a suggestion that for every particle of ordinary matter that constitutes the visible universe, there must exist a corresponding particle with identical mass but opposite electrical charge, an antimatter counterpart that seemed to demand existence by pure mathematical logic. And when this prediction was experimentally confirmed just a few years later with the discovery of the positron, the electron's antimatter twin, physics entered a profound new territory of understanding that would reshape our conception of reality itself. What makes antimatter so conceptually destabilizing is the simple yet catastrophic reaction it produces when brought into contact with ordinary matter. For when a particle meets its antiparticle counterpart, they annihilate one another in a burst of pure energy following Einstein's famous equation, converting their entire mass into radiation in an explosion of devastating efficiency that makes nuclear weapons seem quaint by comparison. And this fundamental interaction represents perhaps the most complete and perfect conversion of matter into energy that physics allows, leaving no residue, no waste, no remainder beyond the light and heat released in that final moment of mutual destruction. The psychological weight of this discovery rests on a peculiar asymmetry that still puzzles physicists to this day, for during the earliest fractions of the Big Bang, matter and antimatter should have been created in exactly equal quantities, and if they had truly been equal, they would have annihilated each other completely, leaving behind only energy and an empty universe devoid of any stars, galaxies, planets, or observers, yet somehow the universe contains vastly more matter than antimatter. A tiny imbalance of perhaps 1 part in a billion that allowed matter to survive and eventually give rise to complexity, consciousness, and the very minds now contemplating this mystery from within the cosmos itself. Imagine standing at the edge of human understanding, where physicists have spent nearly 50 years searching for a single particle that should explain why anything in the universe has mass at all. And in July of 2012, after constructing the largest and most expensive scientific instrument ever built, they finally announced they had found it. The Large Hadron Collider, a 17-mile underground ring beneath the Swiss-French border, smashes protons together at nearly the speed of light, creating conditions so extreme that particles exist for only fractions of a second before decaying into other forms. And within this incomprehensibly violent dance, the Higgs boson occasionally emerges as a fleeting ghost, detected not directly, but through the signature traces it leaves behind. The conceptual mechanism underlying this discovery rests on a theoretical framework developed decades earlier, where physicists proposed that the entire universe is permeated by an invisible field, much like an ocean, and particles gain their mass by interacting with this field as they move through it, with the Higgs boson being the quantum ripple or disturbance in this field itself. This explanation came from the elegant mathematics of the Standard Model, which unified three of the four fundamental forces and predicted the Higgs boson's existence with such precision that scientists knew approximately what mass to search for. Yet finding something so ephemeral required building a machine that cost nearly $10 billion and involved thousands of physicists from across the globe collaborating for decades. What remains remarkable is how thoroughly we have normalized this extraordinary achievement, how a discovery that fundamentally explains why we have bodies and why the universe contains anything substantial at all has become absorbed into the background of scientific knowledge, mentioned briefly in school curricula and then forgotten, as though confirming the nature of mass itself is merely routine progress rather than one of humanity's most profound moments of understanding. In the early 20th century, a German physicist named Albert Einstein sat with pen and paper, wrestling with the implications of his revolutionary theory of general relativity, and among the mathematical predictions that emerged from his equations was something almost too strange to take seriously. The notion that space and time themselves could ripple like the surface of a pond when massive objects accelerated through the cosmos. He called these ripples gravitational waves, and they would represent one of the most profound and elusive predictions in all of theoretical physics, remaining undetected for nearly a century despite being woven into the very fabric of Einstein's most celebrated work. When two neutron stars or black holes spiral toward each other in a catastrophic cosmic dance, the tremendous acceleration of these massive objects warps spacetime itself, creating waves that propagate outward at the speed of light, stretching and compressing the very geometry of the universe as they travel. Yet these waves are extraordinarily subtle, and detecting them requires instruments of almost incomprehensible sensitivity. The conceptual mechanism that makes gravitational waves so difficult to observe lies in their fundamental weakness relative to all other forces in nature, because gravity itself is the weakest of the fundamental interactions, and these ripples in spacetime carry information about some of the most violent events occurring in distant galaxies. Yet by the time they reach Earth, they have diminished to the point where they cause oscillations smaller than a proton's width across a distance of kilometers. When astronomers pointed their telescopes toward the cosmos and began calculating how galaxies actually move through space, they encountered a profound mathematical discrepancy that would reshape our understanding of the universe itself. The visible matter that we can observe, stars, planets, gas clouds, and all the luminous structures we have ever detected, accounts for only about 5% of all the matter that exists in the universe, yet the gravitational effects they measured suggested that far more mass must be present than what they could actually see. Galaxies rotate so quickly that they should fly apart based on the gravitational pull of their visible stars alone, yet they remain intact and coherent, spinning with a consistency that only makes sense if invisible matter surrounds them like a cosmic halo. This missing mass, this gravitational anchor holding galaxies together with an invisible hand, became known as dark matter, and it represents roughly 85% of all the matter in existence. The mechanism behind our acceptance of dark matter lies in the fundamental trust we place in mathematics and observation. When theoretical predictions conflict with what we can detect, scientists accept that the universe contains components beyond human perception rather than abandon the mathematical framework that explains so much else so elegantly. Dark matter reveals itself only through its gravitational influence on visible matter and through the bending of light as it passes through the regions where this invisible substance clusters most densely, a phenomenon called gravitational lensing that provides the only window into its distribution and presence. What remains particularly profound is that despite decades of research and increasingly sophisticated detection experiments, we still do not know what dark matter actually is at the fundamental level, yet we have normalized its existence so completely that modern cosmology simply accepts it as an established component of reality, a cosmic elephant in the room that we navigate around without truly understanding, embodying the deepest mystery of contemporary physics. In the late 1990s, astronomers made an observation so profoundly unsettling that it fundamentally rewrote our understanding of the universe itself. And this observation emerged from studying distant supernovae scattered throughout the cosmos, objects so far away that their light had traveled for billions of years to reach our telescopes on Earth. What these researchers discovered was that the universe was not merely expanding, which scientists had already known for decades, but rather that this expansion was accelerating, speeding up as if some invisible force were pushing all galaxies apart from one another with increasing intensity. And this acceleration contradicted everything that physics had suggested should happen, since gravity, that fundamental force which pulls all matter together, should theoretically be slowing down the expansion rather than hastening it. The logical expectation was that after the Big Bang, the universe would expand rapidly at first, then gradually decelerate as the mutual gravitational attraction of all its matter and energy worked to pull everything back together. Yet the observations indicated the exact opposite was occurring, suggesting that approximately 70% of all the mass and energy in the entire universe consisted of something completely unknown, something that was actively pushing matter apart. And scientists named this mysterious substance dark energy, a placeholder term for a phenomenon that remains fundamentally mysterious even today. The mechanism behind dark energy remains largely theoretical and incompletely understood, with physicists proposing various explanations ranging from the cosmological constant, a uniform energy density that pervades all of space, to more exotic theories involving quantum fluctuations or modifications to the laws of gravity itself at cosmic scales. Yet regardless of which explanation proves correct, the psychological weight of this discovery cannot be overstated, as it means that most of the universe consists of something we cannot see, touch, measure directly, or fully comprehend, something that defies our intuitions about how reality should function. For most of human history, we existed under a profound assumption that our solar system was likely unique, that Earth orbited the Sun in splendid isolation while other stars, those distant points of light, remained forever unknowable and presumably barren of worlds. This belief persisted not because of evidence, but because of the sheer limitation of our instruments and the human tendency to extrapolate from our single example outward to the entire universe. Then in 1995, astronomers detected something extraordinary orbiting a star called 51 Pegasi, a world roughly the size of Jupiter circling its parent star in just 4 days, a discovery that fundamentally inverted our cosmic perspective and suggested that planets were not rare exceptions but abundant features of the galactic landscape. Since that first detection, we have discovered thousands of exoplanets, worlds orbiting distant suns in configurations that often defy our previous understanding of how planetary systems form and organize themselves. The mechanism that allowed this discovery rests on several ingenious techniques, including the transit method, where we observe the slight dimming of a star as a planet passes in front of it, and the radial velocity method, which detects the wobble in a star's light caused by the gravitational pull of orbiting planets. These methods required extraordinary technological precision, the ability to measure variations in light and wavelength at levels that would have seemed impossible mere decades earlier. What makes this discovery so psychologically significant is how it has normalized an entirely new category of existence in our minds, the notion that planets are ubiquitous, that they surround virtually every star in the night sky, that our own solar system is merely one mundane example among countless billions of others. We have integrated this knowledge so thoroughly into our worldview that we rarely pause to consider how radically it transformed our species' position in the cosmos, how it shifted us from potential singularities to merely typical participants in an incomprehensibly vast and populated universe. Imagine for a moment that you're standing in a vast library containing every instruction necessary to build and operate a human being, and that this entire library is compressed into a space so infinitesimally small that it cannot be seen with the naked eye, existing instead as a twisted ladder of molecules spiraling through the nucleus of nearly every cell in your body. This is the genetic code, the molecular language that encodes the blueprint for life itself, and its discovery represents one of the most profound achievements in human understanding. For most of human history, we knew that children resembled their parents, that traits seemed to run in families, yet we possessed no comprehension whatsoever of the mechanism by which this inheritance occurred. Then, in 1953, James Watson and Francis Crick deciphered the structure of DNA, revealing that genetic information is stored in a 4-letter alphabet consisting of nucleotide bases abbreviated as A, T, G, and C, arranged in specific sequences along the DNA molecule. These sequences form codons, 3-letter combinations that act as instructions for building proteins, the fundamental workers of every living cell, and the arrangement of these codons determines everything from your eye color to your susceptibility to certain diseases. The remarkable aspect of this discovery is that this code is essentially universal across all living organisms, meaning that the genetic language spoken by bacteria, plants, and humans is fundamentally the same, suggesting a common ancestral origin for all life on Earth. Yet despite having this complete roadmap to human biology, we continue to be astounded by how little we actually understand about how these genetic instructions translate into the astonishing complexity of a living organism. We have normalized the extraordinary fact that a single fertilized cell contains all the information needed to grow into a being capable of contemplating its own existence, and we move through our lives largely unaware of the continuous symphony of molecular reading and interpretation occurring within us at every moment. Imagine possessing the ability to edit the very blueprint of life itself, to search through the 3 billion letters of human DNA like a reader finding a typo in an ancient manuscript, and then to correct that typo with surgical precision, removing diseases before they ever take root in a person's body. This is the promise of CRISPR, a revolutionary gene editing technology that emerged from the study of how bacteria defend themselves against viruses, a discovery so profound that it fundamentally altered our understanding of what is possible in medicine and biology. The technology works by using a molecular scissors called Cas9 to cut DNA at specific locations, guided by a genetic instruction manual, allowing scientists to delete disease-causing mutations, insert protective genes, or correct inherited disorders that have plagued humanity for millennia. What makes CRISPR so extraordinary is not merely its power, but its accessibility and simplicity compared to previous gene editing methods, making it affordable and straightforward enough for laboratories around the world to utilize. Researchers have already begun using CRISPR to combat sickle cell disease, certain forms of blindness, and various cancers, with clinical trials showing remarkable success rates in treating conditions that were once considered permanent fixtures of the human condition. The technology represents the moment when medicine transitioned from simply managing disease symptoms to actually rewriting the genetic errors that cause suffering at the molecular level. Yet despite possessing this nearly godlike power to reshape human biology, we find ourselves living in a curious state of hesitation, where the full potential of CRISPR remains largely untapped outside of severe disease treatments, constrained by ethical considerations about designer babies and genetic inequality that have become normalized in our discourse. In the year 2000, after more than a decade of intensive international collaboration involving thousands of scientists, hundreds of millions of dollars, and the most advanced computing systems ever assembled, the first complete sequence of the human genome was finally unveiled to the world, revealing the 3 billion base pairs that constitute the fundamental blueprint of human life itself. This monumental achievement represented not merely a cataloging of biological information, but rather a profound shift in humanity's understanding of what we are at the most basic molecular level, as researchers and institutions across the globe had painstakingly mapped out the precise order of nucleotides that encode the instructions for every protein, every cellular function, and every inheritable trait that defines our species. What made this discovery particularly mind-shattering was the realization that despite the extraordinary complexity we observe in human beings, our consciousness, our emotions, our capacity for language and abstract thought, all of this emerges from a relatively modest amount of genetic material, containing approximately 20 to 25,000 genes, a number that proved shockingly similar to that of far simpler organisms, challenging our intuitive sense of biological hierarchy and distinction. The psychological mechanism underlying our astonishment at this discovery stems from a fundamental disconnect between the scale of observable human complexity and the relative simplicity of the genetic instructions that produce it, revealing that much of what makes us human emerges not from the raw quantity of genetic information, but rather from the intricate patterns of gene expression, regulation, and interaction that unfold across our developmental lifetime. Before the 17th century, the invisible architecture of life remained genuinely invisible, a complete mystery hidden beneath the threshold of human perception, and scientists could only speculate about what internal structures might exist within living organisms, imagining vague networks of fluids and spirits rather than anything concrete or measurable. Then in 1665, an English scientist named Robert Hooke peered through an early microscope at a thin slice of cork tissue and observed what appeared to be small rectangular chambers arranged in neat rows, like tiny rooms in a building, and he gave these structures a name that would echo through centuries of biology. Cells, a term borrowed from the Latin word for small rooms found in monasteries. This observation was remarkable, but Hooke could not have fully grasped what he was actually seeing, for these cork cells were in fact dead, providing only the skeletal remains of what living cells truly are, and without understanding their fundamental nature, the significance of his discovery would take nearly 200 years to fully mature. Throughout the 18th century, microscope technology improved with stunning incremental advances, and scientists began observing cells in various living organisms, noticing that these structures appeared universally present in all life forms they examined, from the smallest plants to the largest animals, suggesting something profoundly universal about life's organization. By the early 19th century, a coherent pattern emerged from countless observations and experiments, crystallizing into what became known as cell theory, which posited three revolutionary claims: that all living organisms are composed of one or more cells, that the cell is the fundamental unit of life containing all the structures necessary for living, and perhaps most powerfully, that all cells arise from pre-existing cells through division and reproduction. Within nearly every cell in your body exists a remarkable structure so fundamental to life itself that its discovery fundamentally reshaped our understanding of cellular biology and human existence. The mitochondrion, plural mitochondria, represents one of the most profound mysteries of evolutionary biology because it exists as an almost alien organism embedded within the very fabric of our cells. And this discovery emerged through careful microscopic observation and biochemical analysis that slowly revealed the truth of its origin. Scientists noticed through electron microscopy that these organelles possessed their own double membrane, their own genetic material separate from the nuclear DNA, and their own ability to replicate independently, which created an immediate puzzle that demanded explanation. The leading hypothesis, now supported by overwhelming evidence, suggests that mitochondria are actually ancient bacteria that were engulfed by primitive cells billions of years ago in an event called endosymbiosis. And rather than being digested, these bacteria formed a mutually beneficial relationship where they provided energy production in exchange for cellular protection. What makes this discovery so mind-shattering is the realization that you are not simply a human organism, but rather a complex community of cooperating entities, with mitochondria functioning as the power plants within your cells, converting nutrients and oxygen into adenosine triphosphate, the universal energy currency that powers virtually every biological process you depend on. The psychological weight of this understanding is substantial because it fundamentally challenges our conception of individual identity and autonomy, suggesting that the boundary between self and other, between human and bacterial, is far more blurred than we typically imagine. We have normalized this extraordinary fact through education and casual reference, often treating mitochondria as merely another cellular component rather than recognizing it as a preserved moment of ancient evolutionary fusion, a living fossil embedded within us that rewrites the narrative of what it means to be alive. Consider for a moment the extraordinary machinery that exists within every leaf and blade of grass across our planet, a process so fundamental to life that we rarely pause to contemplate its sheer impossibility before it was discovered. Photosynthesis is the mechanism by which plants, algae, and certain bacteria capture light energy directly from the sun and convert it into chemical energy stored in glucose molecules, essentially transforming pure light into the biological fuel that sustains nearly every living thing on Earth. Within the chloroplasts of plant cells, trillions upon trillions of chlorophyll molecules arrange themselves in precise geometric patterns, absorbing photons of light and becoming energized to such a degree that they tear apart water molecules, releasing oxygen as a waste product while simultaneously capturing electrons and using them to construct sugar from carbon dioxide pulled directly from the air. This process seems almost impossibly elegant because it is solving one of nature's greatest challenges: converting the most abundant energy source available into a storable form that organisms can use on demand, regardless of whether the sun is shining at that exact moment. The psychological breakthrough came when scientists realized that plants were not passively absorbing nutrients from soil as previously believed, but rather were actively manufacturing their own food from inorganic materials through a process driven entirely by light. Early researchers like Jan Ingenhouse and Joseph Priestley observed that plants produced oxygen and consumed carbon dioxide, gradually mapping out the intricate pathways of the light-dependent and light-independent reactions that comprise this astonishing biological machinery. Consider the profound paradox that sits at the very foundation of aerobic life on Earth. The element that makes respiration possible is simultaneously one of the most reactive and destructive substances in our atmosphere, yet we have evolved not only to tolerate it, but to depend upon it absolutely for survival. Oxygen comprises roughly 21% of our air, a concentration that seems almost arbitrary until we examine what happens when it fluctuates even slightly in either direction. When oxygen levels drop below 18%, human cognitive function begins to deteriorate noticeably within minutes, and consciousness itself starts to slip away into the darkness of hypoxia. Conversely, when oxygen concentrations rise above 25%, the risk of spontaneous combustion increases dramatically, and our own cellular machinery begins to suffer oxidative damage from the very element we are breathing. This means that life on Earth exists within an extraordinarily narrow band of atmospheric composition, balanced precariously between suffocation and combustion, between the slow burn of oxidation and the sudden extinction of anoxia. The chemical mechanism underlying this dependency reveals something even more unsettling. Oxygen is fundamentally a corrosive agent. It rusts metals, degrades organic compounds, and damages the delicate structures within our cells through the formation of free radicals and reactive oxygen species. Our entire evolutionary lineage adapted to harness energy from the chemical reactions that oxygen enables, specifically the oxidation of glucose and other molecules within the mitochondria, capturing the tremendous energy released when chemical bonds are broken in the presence of this reactive element. Yet this same process that powers our existence is constantly damaging our cellular machinery, contributing to aging, disease, and ultimately to death itself. Imagine a pendulum swinging back and forth in a perfectly silent room, moving with the same graceful arc hour after hour, never slowing, never faltering, as if time itself has frozen the motion in an eternal dance that defies the very wear and friction we know should eventually drag everything to stillness. Or picture a ball rolling down a hill, transforming its potential energy into kinetic energy with such perfect precision that if you could somehow reverse the hill and roll it back up, it would climb to exactly the same height it started from, asking us to believe that nothing has been lost in the exchange. These are the mental images that underpin one of the most fundamental and quietly profound discoveries in all of science. The principle of conservation of energy, the revelation that energy cannot be created or destroyed, but only transformed from one form into another. What makes this concept so mind-shattering is not merely its mathematical elegance or its predictive power, but rather the almost theological implication that the universe operates under a law of perfect accounting, where every calorie of heat, every joule of motion, every quantum of potential becomes something else, but never truly disappears. When we burn a log in a fireplace, we watch it transform into ash and light and warmth, and the principle tells us that all the chemical energy stored within that wood has simply changed its nature, spreading through the room as thermal energy that will eventually radiate away into the cosmos, never to be recovered but never to be lost from the universe's total ledger. This discovery emerged gradually through centuries of observation and experimentation, from the mechanics of colliding objects to the behavior of heat itself, from the work of engineers and physicists who noticed that nature always seemed to keep perfect count. Yet we have normalized this staggering truth so thoroughly that most of us never pause to feel the vertigo it should inspire, the sense that the universe is governed by an immutable law of equilibrium that suggests a kind of cosmic conservation underlying all existence. Imagine walking into a room that you meticulously organized just this morning, every book aligned on its shelf, every pen placed precisely in its holder, every surface cleared and cleaned with deliberate care. By evening, without any conscious effort on your part, the room has descended into a state of disorder. Papers have scattered across the desk, books lean haphazardly against one another, dust has settled in corners you thought were clean, and the energy you expended to create order seems to have simply evaporated into the atmosphere. This is entropy in action, one of the most profound and unsettling discoveries ever made in physics and in life itself. Entropy is the tendency of the universe to move from order toward disorder, from structure toward chaos, from concentrated energy toward diffuse and useless forms. The second law of thermodynamics, which describes entropy, reveals that in any closed system, the degree of disorder will inevitably increase over time. The psychological mechanism underlying our relationship with entropy is fundamentally about resistance to an inescapable truth. We spend our entire lives fighting against entropy, organizing our homes, maintaining our relationships, preserving our youth, and building civilizations, yet the universe operates according to a principle that makes all these efforts ultimately futile. We have normalized this endless struggle as simply part of human existence, accepting that maintenance is required, that decay must be resisted, that effort must be continuous and eternal. We do not typically sit with the vertigo-inducing realization that entropy is not an enemy to be defeated, but rather a fundamental property of reality itself, that every closed system moves inexorably toward maximum disorder, and that our organized existence is merely a temporary eddy in an ocean of increasing chaos. The universe does not care about our rooms or our bodies or our carefully constructed societies, and entropy continues its infinite march forward with complete indifference to our struggle against it. In the early 20th century, physicists working in laboratories across Europe began to notice something extraordinary happening within the hearts of atoms, a phenomenon that would fundamentally alter the course of human civilization and introduce us to a power so immense that it could reshape continents or reduce them to ash. When a neutron strikes the nucleus of a uranium-235 atom at precisely the right speed, something remarkable occurs. The nucleus does not simply absorb the particle, but rather splits apart into two smaller nuclei, releasing tremendous amounts of energy in the form of heat and radiation, while simultaneously ejecting additional neutrons that go on to strike other uranium atoms in a cascading chain reaction that accelerates exponentially. This discovery emerged from pure theoretical physics, from equations and mathematical predictions about the structure of matter itself. Yet when scientists finally observed this splitting in 1938 in Berlin, they recognized immediately that they had uncovered something that transcended academic curiosity entirely. The realization that a single kilogram of uranium could release energy equivalent to thousands of tons of conventional explosives came with the weight of moral consequence. And within years of this discovery, the world would witness the development of both nuclear weapons and nuclear power plants, technologies that promised unlimited clean energy while simultaneously holding the potential for catastrophic destruction. What persists most remarkably is our continued reliance on this fundamental process despite the existential risks it carries, the way we have normalized living alongside reactors and weapons that could extinguish civilization. Accepting this power as though it were merely another tool in our technological arsenal rather than something we barely understand and can barely control. In 1895, a German physicist named Wilhelm Röntgen was experimenting with cathode rays in his laboratory when he noticed something extraordinary occurring on a nearby fluorescent screen, a glow that should not have been possible given the distance and barriers between his apparatus and the screen, and this mysterious invisible radiation that could pass through solid matter while leaving a photographic impression of the structures beneath prompted him to name this phenomenon X-rays, where X represented the unknown nature of what he had discovered. What Röntgen had encountered was a form of electromagnetic radiation with an extraordinarily short wavelength, energy so concentrated that it could penetrate human flesh, yet be stopped by denser materials like bone and metal. And within weeks of his announcement, the medical establishment recognized the profound implications of being able to visualize the internal architecture of the living body without opening it. A capability that seemed almost miraculous in its departure from all previous medical knowledge and practice. The mechanism underlying X-ray imaging rests upon the simple physical principle that different materials absorb electromagnetic radiation at different rates according to their atomic density. So when X-rays pass through a body, bones and metallic objects absorb more radiation while soft tissues allow more to pass through, and a photographic plate or detector on the other side records this differential absorption as an image showing shadows and highlights corresponding to internal structures. When certain materials are cooled to temperatures approaching absolute zero, something extraordinary occurs that seems to violate everything we understand about how electricity behaves in the physical world. The material suddenly loses all electrical resistance, allowing electric current to flow through it indefinitely without any loss of energy whatsoever, a phenomenon that defies the fundamental friction we expect from moving electrons encountering atomic obstacles. At the moment of this transition, called the critical temperature, the material doesn't gradually become a better conductor. It undergoes a sudden and complete transformation, as if a switch has been flipped in the fabric of reality itself. In superconductors, once you initiate an electric current, it will continue flowing forever with no external power source required, a perpetual motion of electrons that seems to mock the second law of thermodynamics and everything we thought we knew about entropy and decay. The discovery of superconductivity in 1911 by Dutch physicist Huyck Kamerlingh Onnes was so unexpected that it challenged the entire theoretical foundation of materials science and led physicists to completely reimagine how electrons interact with atomic lattices at quantum scales. What makes superconductivity conceptually disturbing is that it demonstrates a macroscopic quantum effect, where the peculiar rules governing subatomic particles suddenly become visible at a scale we can measure and test, blurring the line between the quantum realm and our everyday experience. The electrons in a superconductor form pairs called Cooper pairs, which move through the material in perfect synchrony without scattering, as if the entire electron population has merged into a single quantum wave function that flows around obstacles like water finding its way around a stone. Imagine standing in the laboratories of Bell Telephone in December of 1947, where three physicists named John Bardeen, Leon Brattain, and William Shockley were about to demonstrate something so impossibly small, yet fundamentally transformative, that it would reshape the entire trajectory of human civilization. And yet most people today have never truly paused to consider what a transistor actually is or how it came to be one of the most consequential inventions in modern history. Before this moment, the world relied entirely upon vacuum tubes to amplify electrical signals, massive glass bulbs that glowed with heat and consumed enormous amounts of power while generating tremendous warmth, making computers the size of entire rooms and limiting what humanity could accomplish with electronics. The transistor emerged as a semiconductor device, a crystal of germanium with three terminals that could amplify signals using a fraction of the power, generating almost no heat while occupying a space smaller than a grain of rice. And this seemingly minor improvement would ultimately enable the miniaturization of every electronic device that has since transformed modern existence. What makes the transistor conceptually revolutionary is that it exploits the quantum mechanical properties of semiconductor materials, where electrons moving through specially treated crystals can be controlled and manipulated to amplify weak electrical signals into strong ones, which means that the fundamental mechanism depends entirely upon understanding how subatomic particles behave in ways that defied classical physics. The deeper psychological reality is that transistors enabled abundance where scarcity once reigned, and yet we have become so accustomed to their omnipresence that we rarely acknowledge their existence or significance in enabling the smartphones, computers, and countless devices that structure our daily lives, much as we breathe air without contemplating the oxygen molecules that sustain us. Imagine standing in a laboratory in 1958 when physicists first managed to create a beam of coherent light so perfectly organized, so impossibly concentrated, that it could burn through steel and etch patterns into diamond with surgical precision. The laser, an acronym for light amplification by stimulated emission of radiation, represents one of humanity's most counterintuitive achievements, because it took the most common thing in our universe, ordinary light, and forced it to behave in a way that seems to violate our everyday understanding of how light actually works. Before the laser, light was always understood as something that naturally spreads outward, scattering in all directions from its source like ripples on water, a phenomenon so fundamental that it shaped our entire physics for centuries. Yet through a process involving excited atoms releasing photons in perfect synchronization, scientists discovered that light could be made to move in lockstep, all photons traveling in the same direction with identical wavelengths and phases, creating an intensity so concentrated that it could accomplish feats that seemed impossible. The laser works through a mechanism called stimulated emission, where an atom that has been energized to an excited state can be triggered by an incoming photon to release another photon with identical properties, creating a cascading effect where one photon becomes two, then four, then millions, all moving together in perfect coherence. What makes this discovery so psychologically remarkable is that it required scientists to fundamentally reimagine the nature of light itself, moving beyond the classical understanding to embrace quantum mechanical principles where particles could be coerced into cooperative behavior through the right stimulation and containment. Imagine standing in a completely ordinary room, surrounded by furniture and objects you've touched countless times, and being told that invisible waves of energy are constantly passing through your body, through the walls, through the earth itself, carrying voices and music and information from sources hundreds of miles away. This is the reality of radio waves, a discovery so fundamental to modern existence that we have rendered it entirely invisible in our consciousness, despite the fact that it represents one of the most profoundly strange aspects of our physical reality. Radio waves are electromagnetic radiation, a form of energy that travels at the speed of light, with wavelengths ranging from about 1 millimeter to over 100 kilometers in length, and they are perpetually washing over us in an invisible ocean of transmitted signals. The mechanism behind radio communication rests upon a principle so elegant that it seems almost impossible when first confronted. A vibrating electrical charge creates a disturbance in the electromagnetic field, and this disturbance propagates outward in all directions at the speed of light, maintaining the pattern of the original vibration encoded within its structure. When a transmitter sends an audio signal through radio waves, the sound itself is first converted into an electrical signal, then used to modulate a high-frequency carrier wave, meaning the information is essentially imprinted upon this invisible electromagnetic carrier like a pattern on water. On the receiving end, an antenna captures these waves, and a tuning circuit selects only those frequencies of interest, allowing the information to be extracted and converted back into the original sound. What makes this discovery so conceptually disorienting is that we have now normalized the idea of information traveling invisibly through space. Yet this remains one of the most startling revelations about the nature of reality itself. For millennia, humanity operated under the assumption that our planet was remarkably young, with religious scholars and theologians calculating the Earth's age based on genealogical records and ancient texts, arriving at figures suggesting our world was only a few thousand years old, yet the actual age of Earth, approximately 4.5 billion years, remained hidden beneath layers of rock fossil records and radioactive isotopes that would not reveal their secrets until the development of modern scientific methodology in the 19th and 20th centuries. The discovery emerged gradually through the work of geologists and physicists who began to understand that certain elements decay at predictable rates, creating a natural clock embedded within the very stones beneath our feet, and by measuring the ratio of parent isotopes to daughter isotopes in rocks and meteorites, scientists could calculate with remarkable precision when these materials first solidified, pushing back humanity's conception of planetary history by an almost incomprehensible margin. What makes this discovery so profoundly disorienting is not merely the vast span of time itself, but rather the way it fundamentally repositioned human existence within a temporal framework so expansive that our entire recorded history, all 5,000 years of civilization, all of written language and organized society, represents merely the final 0.1% of our planet's existence. A temporal proportion so minute that if Earth's entire history were compressed into a single calendar year, modern human civilization would occupy less than 4 seconds on New Year's Eve. Beneath the surface of the Earth lies an almost incomprehensibly vast library of ancient life forms, preserved in stone and sediment across billions of years, where the remains of creatures that once walked, swam, and flew have been compressed and mineralized into tangible evidence of the deep past, creating a chronological narrative written in rock that spans from the earliest single-celled organisms to the magnificent megafauna that roamed the continents before humans ever existed. When paleontologists excavate these sites, they encounter layer upon layer of geological strata, each one representing a distinct period in Earth's history, and within these layers they discover bones, shells, teeth, and even preserved soft tissues that tell stories of species that thrived for millions of years before vanishing entirely, replaced by entirely different forms of life adapted to new environmental conditions. The fossil record functions as a documentary of evolution itself, showing not just isolated snapshots of extinct creatures, but rather demonstrating clear patterns of descent with modification, where intermediate forms bridge the gaps between major groups of animals, revealing how fins became limbs, how land-dwelling mammals returned to the ocean, and how dinosaurs gradually transformed into birds through a continuous series of incremental changes. The psychological mechanism that makes the fossil record so compelling is that it provides concrete, tangible proof of phenomena that would otherwise remain theoretical and difficult to visualize, allowing us to hold in our hands a piece of something that lived millions of years ago. And this physical connection creates an undeniable sense of continuity between the present world and a radically different past that challenges our natural human tendency to view the world as relatively static and unchanging across time. 66 million years ago, a massive asteroid roughly 10 kilometers in diameter struck the Yucatan Peninsula in present-day Mexico, releasing energy equivalent to billions of nuclear weapons detonating simultaneously. And in that singular moment, the reign of the dinosaurs came to a catastrophic end, along with approximately 75% of all life on Earth, fundamentally reshaping the trajectory of biological evolution and clearing the stage for mammals. And eventually humans to rise to dominance. The impact created a crater nearly 200 kilometers wide, triggered earthquakes of unimaginable magnitude, vaporized rock and dust that blocked out the sun for months, caused global temperatures to plummet, disrupted photosynthesis across the planet, and set off a cascading collapse of food chains that devastated ecosystems from the deepest oceans to the highest mountains. Yet what makes this discovery so psychologically profound is not merely the violence of the event itself, but rather the realization that life as we know it exists in a precarious state, hanging by the thinnest of threads, dependent upon the continued stability of our planetary system, and vulnerable to cosmic forces entirely beyond our control or prediction. The mechanism that makes this discovery so mind-altering stems from our deeply ingrained psychological need to believe in permanence and stability, to assume that the world operates according to predictable natural laws we can comprehend and manage. And the asteroid extinction shatters that illusion completely by demonstrating that extinction is not a gradual process of competitive struggle, but rather something that can occur suddenly and absolutely, erasing dominant life forms that thrived for millions of years in mere moments of geological time. For roughly 170 million years, dinosaurs dominated nearly every terrestrial ecosystem on Earth, evolving into thousands of distinct species that ranged from creatures smaller than modern chickens to titanosaurs weighing as much as 10 African elephants combined. Yet we have never seen a living dinosaur and only know them through fragmented fossil records, incomplete skeletal remains, and educated scientific inference. The discovery of dinosaurs fundamentally altered human understanding of deep time and extinction, beginning in the early 19th century when geologists and paleontologists recognized that the massive fossilized bones scattered throughout Europe and North America belonged to an entirely extinct class of reptilian organisms that had walked the planet for an incomprehensibly vast span of geological history. What makes this discovery psychologically remarkable is that dinosaurs represent something the human mind struggles to fully comprehend. A complete and utter absence, a time so remote and a world so fundamentally different from our own that we can only reconstruct it through scientific methodology and imaginative extrapolation from the barest physical evidence. We have never observed them, never heard them, never witnessed their behavior, yet we have built entire frameworks of understanding about their biology, physiology, locomotion, and ecological relationships based on bone density, tooth wear patterns, fossilized footprints, and comparative anatomy with modern reptiles. The psychological impact of dinosaurs persists so powerfully in human culture despite this fundamental epistemic gap, because they represent the ultimate humbling of human perception and the ultimate vindication of deep time. They prove that entire worlds have come and gone, that dominant species can vanish completely, that the Earth operates on timescales so vast that recorded human history is merely a microsecond. Imagine standing on a beach and watching the waves crash against the shore, knowing that the very ground beneath your feet is moving across the planet at a speed roughly equivalent to how fast your fingernails grow, imperceptibly, yet inevitably relocating entire continents across millions of years in a slow waltz that reshapes the entire geography of the world. Continental drift, the revolutionary concept that the continents are not fixed and permanent fixtures of our planet, but rather vast slabs of the Earth's crust that float upon the underlying mantle, moving horizontally across the globe, in response to the enormous forces generated by the planet's internal heat and the convective currents that drive the lithosphere, represents one of the most profound paradigm shifts in our understanding of the physical nature of the Earth itself. The mechanism that allows this planetary-scale movement operates through the process of plate tectonics, where the Earth's outer shell is divided into several plates that constantly move in relation to one another, driven by the heat rising from the planet's interior, which creates convection currents in the mantle that slowly push and pull these continental and oceanic plates across the surface, causing them to collide, separate, and slide past one another in a perpetual dance of geological transformation. What makes this discovery psychologically fascinating is how the human mind struggles to reconcile the apparent permanence of continents with their actual fluid nature. Since our lifespans are so insignificantly brief compared to geological time scales that the movement becomes invisible to our direct experience, allowing us to maintain an intuitive sense of the Earth as unchanging and eternal, even as we intellectually accept that Africa and South America were once joined together, and that the Atlantic Ocean continues to widen as the plates separate. Beneath the thin crust upon which we walk and build our civilizations lies a realm of incomprehensible heat and pressure, a vast sphere of molten iron and nickel suspended in the depths of our planet, rotating at its own pace and generating the magnetic field that shields us from the solar wind. This outer core, churning at temperatures comparable to the surface of the Sun, remains perpetually liquid due to the immense gravitational compression surrounding it, and within it convection currents move with the deliberate slowness of geological time, yet with enough force to reshape continents and fuel the volcanic activity that has both created and destroyed countless forms of life throughout Earth's history. The discovery of this molten layer emerged gradually through the patient work of seismologists who studied how earthquake waves traveled through the planet, noting that certain seismic waves would disappear at specific depths, while others continued onward, revealing the presence of liquid material that could not support the transmission of shear waves in the way solid rock could. What makes this discovery so conceptually challenging is that we have never directly observed this molten core, and we likely never will, for the deepest human excavation reaches only about 8 miles down, while the outer core begins nearly 2,000 miles beneath our feet, existing in a realm so extreme that even the most sophisticated instruments can only infer its properties through indirect means. We have normalized the existence of this hidden furnace beneath our feet by integrating it into our understanding of plate tectonics and planetary dynamics. Yet the reality of walking upon such an enormous sphere of liquid metal, knowing that we float upon a thin solid shell above temperatures exceeding 9,000 degrees Fahrenheit, presents a profound disconnect between our everyday experience of stability and the violent, turbulent reality of the world's internal structure. High above the Earth's surface, suspended in the stratosphere between 10 and 50 kilometers altitude, exists an invisible shield composed of a peculiar form of oxygen called ozone, and this delicate molecular layer represents one of the most consequential discoveries in modern science, fundamentally reshaping how humanity understands both its vulnerability and its capacity for collective action in the face of existential threats. The ozone layer absorbs the majority of the sun's ultraviolet radiation, specifically the most harmful ultraviolet B rays that would otherwise penetrate to the surface and cause widespread biological devastation, including skin cancer, cataracts, immune system suppression, and the disruption of entire marine ecosystems that form the foundation of global food chains. For most of human history, this protective layer functioned silently and invisibly, doing its vital work without any conscious human awareness of its presence or importance. Yet in the 1970s, scientists discovered something profoundly alarming. The ozone layer was rapidly thinning, particularly over the Antarctic region where a massive seasonal hole was expanding each spring, and chemical analysis revealed the culprit to be chlorofluorocarbons, or CFCs, synthetic compounds that had been widely adopted for use in refrigerators, air conditioners, aerosol sprays, and foam insulation because they were considered safer alternatives to more toxic substances. Imagine a blanket wrapping around the entire planet, one so thin and invisible that we cannot see it with our eyes, yet so powerful that it traps the warmth of the sun and prevents it from escaping back into the void of space. This is the greenhouse effect, a phenomenon so fundamental to our planetary existence that without it, Earth would be a frozen, lifeless rock orbiting in the darkness. The mechanism itself is elegantly simple. Sunlight enters our atmosphere and warms the surface of the planet, and that warmth radiates back upward as infrared radiation, seeking to escape into space. However, certain gases in our atmosphere, primarily carbon dioxide, methane, and water vapor, act as a selective barrier, allowing visible light to pass through while trapping the infrared heat below like panes of glass in an actual greenhouse. This process has existed for billions of years, creating a delicate balance that has allowed life to flourish in a temperate climate zone. The logical underpinning of this discovery, made gradually by scientists throughout the 1800s and refined ever since, reveals that the greenhouse effect itself is not inherently dangerous. Rather, it is the strengthening of this effect through human activity that has become the concern. We have been burning fossil fuels at an unprecedented rate for the past 2 centuries, releasing ancient carbon that had been locked underground for millions of years, fundamentally altering the composition of our atmosphere. Yet despite our complete scientific understanding of this mechanism, despite having the knowledge to predict its consequences with remarkable accuracy, humanity continues to operate as though this invisible blanket can absorb infinite additional layers of gases without consequence. We have normalized the contradiction between knowing and acting, between understanding the mechanism and refusing to change our behavior, creating a peculiar cognitive dissonance where the clarity of the science somehow makes the inaction even more profound. For most of human history, the movement of blood through the body remained one of medicine's deepest mysteries, and the false certainties that ancient physicians held onto shaped medical practice for nearly 2,000 years in ways that seem almost incomprehensible from our modern perspective. Galen, the influential Roman physician, believed that blood was produced in the liver and then consumed by the body's tissues, that it did not actually circulate, but rather moved back and forth in a kind of tidal motion through vessels, and that the heart was primarily an organ of heat rather than a pump, a fundamental misunderstanding that persisted through the medieval period and into the Renaissance despite mounting evidence to the contrary. The actual discovery of blood circulation came through William Harvey, an English physician working in the early 17th century, who through meticulous observation and mathematical calculation demonstrated that blood must move in a closed loop through the body, that the heart functions as a muscular pump, and that blood is pushed through arteries into capillaries where it exchanges oxygen and nutrients before returning through veins back to the heart in an elegant and perpetual cycle. What makes this discovery psychologically fascinating is how physicians before Harvey could have reasoned their way to this truth simply by observing that the amount of blood leaving the heart through arteries far exceeded what the body could possibly manufacture from food and water. Yet the weight of established authority and the difficulty of challenging dogma that had been taught for generations prevented them from recognizing what should have been obvious. Demonstrating how institutional inertia and deference to ancient authorities can blind even learned individuals to basic observable facts. Imagine a time when surgeons had to operate on fully conscious patients who could feel every incision, every cut through tissue, every saw through bone, all while being physically restrained to prevent them from thrashing away in agony, and picture the surgeon working as quickly as possible to minimize suffering, knowing that speed was the only mercy available. Until one remarkable day in the 1800s, when a dentist named William T.G. Morton administered ether vapor to a patient before a surgical procedure, and the man fell into an unconscious state while surgeons operated on his neck without a single scream or struggle. And when he awoke, he had no memory of pain, no recollection of the procedure itself, only the bizarre gap in his consciousness and the knowledge that something profound had changed forever in the history of human medicine. The mechanism behind anesthesia involves a complex interplay of neurochemical interactions where certain substances, whether volatile liquids like ether and chloroform or modern intravenous agents like propofol, suppress the activity of the central nervous system in such a way that consciousness becomes disconnected from sensory input, preventing the brain from processing pain signals while simultaneously erasing the formation of memories during the procedure. Creating a state where the body remains alive and functional, yet the mind enters a void, a temporary death-like state that allows surgeons to work without causing psychological trauma to their patients. Imagine a world before the late 1800s, where a simple cut or surgical wound was as likely to kill you as it was to heal, where infection ravaged battlefields and hospitals with such devastating regularity that more soldiers died from infected wounds than from the actual combat itself, where childbirth fever claimed countless mothers in what should have been moments of joy, and where physicians operated with bare hands and unwashed instruments. Completely unaware that invisible microscopic organisms were the true architects of death. Then came the gradual revelation that germs existed, that these submicroscopic life forms were responsible for disease and decay, and that by introducing certain chemical substances to wound sites and surgical tools, the rate of infection could be dramatically reduced, fundamentally transforming the landscape of human medicine and survival. The mechanism behind antiseptics operates on a surprisingly straightforward principle. These chemical agents either kill microorganisms outright through cellular damage, disruption of their membranes, or interference with their metabolic processes, or they inhibit their growth and reproduction by creating an environment hostile to their survival. And this discovery emerged gradually through the experimental work of pioneers like Joseph Lister, who noticed that carbolic acid spray during surgery dramatically reduced postoperative infections, leading to the revolutionary practice of antiseptic surgical technique. For nearly 3,000 years, smallpox ravaged human civilization with an almost incomprehensible brutality, killing an estimated 300 million people throughout the 20th century alone, leaving countless survivors permanently disfigured with deep pitting scars across their faces and bodies, blinding millions. And becoming so deeply embedded in human experience that entire cultures developed elaborate rituals and prayers specifically designed to appease what they believed to be the spiritual forces behind the disease. Yet despite its devastating prevalence and the seemingly insurmountable challenge of eradicating a pathogen that had survived every previous attempt at control, a coordinated global campaign beginning in 1967 managed to accomplish what many experts considered impossible: the complete elimination of this ancient scourge from the human population through a combination of widespread vaccination programs, surveillance networks that tracked outbreaks across continents, rapid response teams that could contain infections at their source, and the persistent dedication of healthcare workers who ventured into remote villages and marginalized communities to ensure universal vaccine coverage. The psychological mechanism that made this achievement possible rested on a fundamental shift in how humanity conceived of infectious disease, moving away from fatalistic acceptance toward the belief that systematic, organized effort could actually reshape the biological landscape itself. And this required an extraordinary alignment of political will across nations that were often in direct conflict with one another during the Cold War, suggesting that the eradication succeeded not through any single technological breakthrough, but rather through the application of existing tools with unprecedented coordination and commitment. Before the 20th century, a diagnosis of diabetes mellitus was essentially a death sentence, a slow and agonizing decline as the body consumed itself from within, unable to process the very glucose that sustained life. Patients would waste away despite eating, their tissues breaking down in desperation as their cells starved for energy they could not access, and physicians could offer nothing but comfort and the grim certainty of approaching death. Then in 1921, Frederick Banting and Charles Best conducted a series of experiments on dogs, removing their pancreases and observing the rapid onset of diabetic symptoms, before extracting a mysterious substance from the pancreatic tissue of healthy animals and injecting it into the diabetic dogs, watching in astonishment as their blood sugar normalized and their suffering ceased. This substance, named insulin, represented one of the most profound reversals of human fate ever achieved, transforming a uniformly fatal condition into a manageable chronic disease that patients could live with for decades. The mechanism underlying insulin's miraculous action is elegant in its simplicity. Insulin is a peptide hormone that acts as a cellular gatekeeper, binding to receptors on the surface of muscle and fat cells, essentially unlocking the door so that glucose can enter from the bloodstream and be metabolized for energy, while simultaneously signaling the liver to store excess glucose as glycogen for future use. Without adequate insulin production or cellular response, glucose accumulates uselessly in the blood while cells struggle in deprivation, a cruel biochemical paradox where abundance and scarcity exist simultaneously. Consider for a moment the profound reality that your thoughts, your emotions, your desires, and your very sense of self are not entirely your own, but rather the products of invisible chemical messengers coursing through your bloodstream at any given moment. Hormones are organic compounds produced by your endocrine glands that travel throughout your body, binding to specific receptors on cells, and fundamentally altering how those cells behave, think, and feel. Yet most people move through their entire lives barely acknowledging this biochemical puppet mastery. A woman might wake up one morning convinced that her partner is unbearably irritating, experiencing genuine rage at habits she found endearing just days before, not realizing that her estrogen and progesterone levels have shifted dramatically due to her menstrual cycle, literally rewiring the emotional tone of her entire consciousness. A teenager experiences inexplicable mood swings and sudden self-consciousness not because of external circumstances, but because testosterone and growth hormone are flooding through their body in unprecedented quantities, restructuring their brain chemistry and their very personality along with it. During times of stress, cortisol floods your system, narrowing your vision, elevating your heart rate, and making you hypervigilant to threats, responses that made sense when danger was immediate and physical, but that now trigger anxiety in traffic jams and during email conversations, your body unable to distinguish between a predator and a deadline. The mechanism behind all this is elegantly simple yet staggeringly complex. Your brain produces hormones like oxytocin that make you fall in love, vasopressin that binds you to partners, and dopamine that makes you chase pleasure and reward, meaning that your most intimate relationships and your deepest sense of meaning are fundamentally chemical events occurring in your body without your conscious permission. Deep within the intricate landscape of your brain exists a chemical conversation so profound and continuous that it orchestrates nearly every thought you have ever experienced, every emotion you have ever felt, and every movement your body has ever executed. Yet most people go through their entire lives completely unaware of this invisible molecular symphony playing out in the 3 pounds of tissue residing inside their skulls. Neurotransmitters are small chemical messengers that travel across the microscopic gaps between neurons called synapses, carrying signals from one brain cell to another in a process so fundamental to consciousness itself that without them, you would cease to exist as a thinking, feeling being in any meaningful sense. When a neuron fires, it releases these neurotransmitter molecules into the synapse, and they drift across that tiny space before binding to receptors on the receiving neuron, either exciting it to fire or inhibiting it from doing so. And this binary dance of activation and suppression across trillions of synaptic connections creates the substrate upon which all neural computation depends. The major neurotransmitters like dopamine, serotonin, acetylcholine, glutamate, and gamma-aminobutyric acid each have specialized roles. Dopamine drives motivation and reward-seeking behavior, serotonin regulates mood and emotional stability, acetylcholine facilitates memory formation and attention, glutamate excites neural activity, and GABA dampens it. And these systems work in concert to maintain the delicate chemical balance that allows your brain to function. What makes neurotransmitter discovery particularly mind-shattering is that these molecules explain so much of human experience that once seemed mystical or purely psychological. Depression correlates with low serotonin, addiction involves hijacking dopamine pathways, anxiety manifests through dysregulation of multiple neurotransmitter systems, and even consciousness itself appears dependent on proper neurotransmitter balance. Consider for a moment the fundamental architecture of thought itself, the microscopic gaps that exist between the billions of neurons in your brain, spaces so infinitesimally small that they were invisible to science for centuries, yet so profoundly consequential that every memory you possess, every emotion you've ever felt, and every conscious experience you've ever had depends entirely upon what happens within them. These gaps are called synapses, and they represent perhaps one of the most elegant and bewildering discoveries in the history of neuroscience, a revelation that fundamentally altered our understanding of consciousness, learning, and the very nature of what makes us who we are. When scientists first began studying the brain in earnest during the 19th century, they assumed that neurons formed a continuous network, a kind of biological highway system where electrical impulses traveled uninterrupted from one cell to the next without obstruction or interruption of any kind. Yet careful microscopic examination revealed something far more intricate and mysterious, that neurons do not actually touch one another, but instead maintain these precise, carefully measured gaps that neurotransmitter molecules must somehow traverse to communicate between cells. The synapse operates through a process of chemical transmission that seems almost impossibly complex when you consider its microscopic scale, where electrical signals arriving at the end of one neuron trigger the release of chemical messengers that diffuse across this gap and bind to receptors on the neighboring neuron, either exciting or inhibiting its activity in ways that collectively produce the phenomenon we call thought. What remains profoundly fascinating is how these synapses are not fixed and unchanging structures, but rather dynamically responsive entities that strengthen or weaken based on experience and use, a phenomenon called synaptic plasticity that forms the biological basis of learning and memory itself. For most of human history, scientists believed that the adult brain was essentially fixed, a rigid organ whose neural pathways were established in childhood and remained largely unchanged throughout the rest of our lives. Yet over the past several decades, researchers have discovered something far more remarkable. The brain possesses an extraordinary capacity to reorganize itself, to form new neural connections, and to fundamentally rewire its own architecture in response to experience, learning, and even injury. This property, known as neuroplasticity or brain plasticity, emerged from observations of stroke patients who regained lost functions through intensive rehabilitation, and from studies of London taxi drivers whose hippocampi visibly enlarged after years of memorizing complex street maps, and from children born with large portions of their brains removed or damaged who developed relatively normal cognitive abilities because neighboring regions expanded to assume the responsibilities of the damaged tissue. The mechanism underlying this phenomenon involves the fundamental principle that neurons that fire together wire together, a concept called Hebbian learning, where repeated activation of neural pathways strengthens the synaptic connections between neurons, while unused pathways gradually weaken through a process of pruning, meaning that every thought we think, every skill we practice, and every experience we have physically alters the microscopic architecture of our brains at the molecular level. What makes this discovery so profound is how thoroughly it contradicts centuries of neuroscientific dogma that portrayed the brain as essentially unchangeable after early childhood, a biological determinism that seemed to lock our cognitive abilities, personalities, and potential into place before we fully understood ourselves. Yet the evidence for plasticity has become so overwhelming that it has fundamentally reshaped how we approach learning, recovery from brain injury, and the treatment of neurological conditions. Every single night, your body cycles through a peculiar and profound state of consciousness where your eyes dart rapidly beneath closed lids, your muscles become paralyzed except for your diaphragm, and your brain generates vivid, often bizarre narratives that feel absolutely real in the moment, only to dissolve into obscurity moments after you wake. This is REM sleep, which stands for rapid eye movement sleep, and it represents one of the most mysterious and essential components of human physiology that we've only begun to truly understand in the past several decades. During these periods, which typically occur in cycles throughout the night and comprise roughly 20 to 25% of an adult's total sleep time, your brain becomes nearly as active as it is during waking consciousness, flooding your neural pathways with neurotransmitters like acetylcholine while simultaneously suppressing the production of serotonin and norepinephrine, creating the neurochemical conditions necessary for dreaming. The mechanism behind this state appears to serve multiple critical functions, including memory consolidation, emotional processing, and the maintenance of neural circuits and synaptic connections that might otherwise deteriorate through disuse. Your brain seems to be rehearsing scenarios, processing experiences from the day, and integrating emotional content into long-term memory storage during these vivid dream periods. Yet the peculiar nature of REM sleep is that it remains fundamentally inaccessible to your conscious mind, leaving behind only fragmented impressions and feelings rather than coherent narratives. Imagine sitting in a room watching someone pick up a hot cup of coffee, and as you observe them lifting it to their lips, you feel a subtle sensation of warmth spreading through your own hands, even though you are nowhere near any heat source. Or consider the moment when you see a friend stub their toe on a table leg, and instantly you wince, your body tensing as if you yourself had experienced that sharp pain. These are not flights of imagination or mere empathetic flourishes born from your conscious effort to relate to another person's experience. Instead, these moments represent the activation of a remarkable system of neurons within your brain that fire both when you perform an action and when you observe someone else performing that same action, creating an automatic bridge between watching and doing. Scientists first discovered these mirror neurons in the 1990s while studying macaque monkeys in a laboratory setting in Italy. when researchers noticed that individual neurons in the premotor cortex responded identically whether a monkey picked up a peanut or watched another monkey perform the exact same gesture. The existence of these neurons fundamentally changed our understanding of how human empathy, learning, and social connection operate at the neurological level, suggesting that we are quite literally wired to simulate the experiences of those around us without any conscious deliberation required. Mirror neurons appear to create an internal model of observed actions within our own motor systems, allowing us to understand not just what someone is doing, but implicitly understanding why they are doing it and what it might feel like to do it ourselves. This neurological mechanism seems to underlie our ability to learn through observation, to understand intentions, to feel genuine compassion for others, and to engage in the complex dance of human social interaction. Consider for a moment the extraordinary discovery that within the human brain exists a fundamental unit of biological architecture called the neuron, a microscopic structure so infinitesimally small that billions upon billions of them can exist within the confines of your skull. Yet each one possesses the remarkable capacity to store information, transmit electrical signals, and participate in the formation of consciousness itself. When Santiago Ramon y Cajal first observed these delicate branching structures through his microscope in the late 1800s, using a revolutionary silver staining technique that rendered them visible for the first time in history, he encountered something that seemed to defy the very notion that consciousness could emerge from physical matter. What he saw were individual cells with a central body called the soma, thread-like extensions called axons and dendrites that reached outward like the branches of an ancient tree, creating pathways of connection between one neuron and countless others, and it became apparent that thought, memory, emotion, and identity itself must somehow arise from the electrochemical conversations occurring across these microscopic synapses. The mechanism behind this discovery reveals something profoundly unsettling. Each neuron communicates with others by releasing chemical messengers called neurotransmitters across a gap called the synapse, a process so delicate and precise that a single neuron can form tens of thousands of connections, creating networks of staggering complexity where the strength of each connection can be modified through experience, meaning that your thoughts and memories are literally encoded in the physical reshaping of these neural pathways every single moment of your existence. In the depths of biological laboratories around the world, scientists have discovered cells that possess a peculiar and almost mystical quality: the ability to transform into virtually any cell type in the human body, remaining indefinitely young and capable of dividing without limit. These are stem cells, and their discovery represents one of the most profound revelations about the nature of life itself, fundamentally challenging our understanding of what it means for a cell to have identity and purpose. Unlike specialized cells such as neurons or heart muscle cells, which have committed themselves to a single function, stem cells exist in a state of remarkable plasticity, maintaining within their genetic material the potential to become anything at all. This quality emerges from their unique position within the cellular hierarchy. They possess both the ability to self-renew through cell division, creating more stem cells, and the capacity to differentiate into specialized cells through a process of gradual commitment to specific lineages. The mechanisms driving this transformation involve complex networks of genes and proteins that switch on and off in orchestrated patterns, responding to chemical signals from their environment and creating what scientists call epigenetic changes, modifications that alter which genes are expressed without changing the underlying DNA sequence itself. What makes stem cells truly remarkable is that this process operates through entirely naturalistic means, requiring no external intervention or guidance beyond the chemical environment in which these cells find themselves. Yet despite decades of research and the accumulation of extraordinary evidence regarding stem cell biology, these cells have become surrounded by an almost mythological aura in public consciousness, celebrated as potential cure-alls for virtually every human ailment while simultaneously being subject to intense ethical and political scrutiny. For decades, scientists operated under the assumption that your genes were your destiny, that the sequence of DNA you inherited at birth was fixed and immutable, determining with near certainty the arc of your health, your vulnerabilities, and the biological future that awaited you. Yet beginning in the late 1990s and accelerating through the 2000s, researchers began discovering something that fundamentally challenged this understanding: that genes themselves could be turned on and off like switches, their activity modulated by chemical tags and modifications that sit atop the DNA strands without altering the genetic code itself. This field, known as epigenetics, revealed that your life experiences, your diet, your stress levels, even your mother's experiences before you were born, could leave molecular fingerprints on your genes, silencing some and amplifying others in ways that could persist throughout your life and potentially pass to your offspring. The mechanism operates through processes like DNA methylation, where methyl groups attach to cytosine bases and typically silence genes, and histone modification, where proteins that package DNA can be chemically altered to make genes more or less accessible to the cellular machinery that reads them. What makes this discovery truly mind-altering is the realization that identical twins, born with the same genetic sequence, begin to show different patterns of gene expression as they age and experience different lives, their epigenetic markers diverging measurably over time. Studies on Dutch children who experienced famine during the winter of 1944 revealed that their descendants, decades later, showed altered methylation patterns and metabolic differences linked to that ancestral trauma, suggesting that environmental stress could literally mark the genome across generations. In the closing decades of the 20th century, molecular biologists made a discovery so fundamental, so quietly revolutionary, that most of the world remained entirely unaware of its existence until a global pandemic forced the concept into the spotlight. Messenger RNA, or mRNA, represented something almost paradoxical in nature. A temporary instruction manual, a piece of genetic information that was never meant to last, yet somehow capable of directing the entire machinery of a cell to manufacture exactly what was needed, exactly when it was needed, and then simply disappear. For decades, this molecule remained confined to laboratories and academic journals, a molecular footnote in the grand narrative of genetics, while scientists marveled at its elegant simplicity. The molecule itself was remarkably straightforward in its function. It was essentially a copy of a gene that traveled from the nucleus of a cell to the cytoplasm, carrying instructions for protein synthesis written in a four-letter chemical alphabet. What made mRNA genuinely extraordinary was its transience, its temporary nature, which meant it could be produced in response to immediate cellular needs without permanently altering the genome. Yet despite this fundamental elegance and this tremendous potential for therapeutic intervention, the scientific community struggled for generations to figure out how to weaponize this knowledge, how to harness mRNA as a tool for medicine rather than merely as an object of study. The psychological breakthrough came not from a sudden flash of insight, but from a gradual acceptance that the traditional approach to vaccines had inherent limitations, that perhaps you did not need to inject weakened viruses or viral components if you could simply instruct the body's own cells to manufacture the protein needed to trigger an immune response. This conceptual shift, from introducing a foreign substance to teaching the body's own machinery to produce what was needed, represented a fundamental reorientation of how we think about medicine itself. Imagine a world where the miraculous drugs that saved millions of lives throughout the 20th century gradually lose their power, rendering themselves useless against the very infections they were designed to eliminate. And this is not a distant hypothetical scenario, but rather an ongoing crisis that is reshaping modern medicine in profound and unsettling ways. Antibiotic resistance emerges from a deceptively simple biological principle. Bacteria, like all living organisms, possess the capacity to evolve and adapt to their environment, and when antibiotics are introduced into a population of bacteria, the vast majority are killed, but inevitably, small fraction carry genetic mutations that allow them to survive the chemical assault, and these survivors then reproduce rapidly in the absence of competition, creating a new generation of bacteria that can withstand the very drug that once would have eliminated them entirely. This process represents evolution in real time, occurring not over millennia, but across mere weeks or months, amplified dramatically by the overuse and misuse of antibiotics in hospitals, farms, and homes worldwide, where antibiotics are prescribed for viral infections they cannot treat, administered in incomplete courses that leave behind the most resilient bacteria, and routinely fed to livestock in subtherapeutic doses to promote growth, effectively creating incubators for resistance on a massive scale. The mechanism underlying this phenomenon is elegant and inexorable. Bacteria reproduce asexually and possess plasmids, small circular pieces of DNA that can transfer resistance genes directly from one bacterium to another, even across species boundaries, meaning that resistance does not remain confined to a single bacterial strain, but spreads like wildfire through microbial communities, converting a localized problem into a global pandemic of medical futility. Within the dark and intricate passages of your digestive system, on the surface of your skin, and throughout nearly every crevice of your body, there exists an entirely separate civilization of microscopic organisms that outnumber your own cells by a factor that stretches the human imagination. And for the vast majority of human history, we remained completely unaware of this hidden world that was orchestrating our health, our behavior, and our very survival in ways we are only now beginning to comprehend. These trillions upon trillions of bacteria, fungi, viruses, and other microorganisms collectively form what scientists call the microbiome, a biological entity so fundamental to human existence that it might be more accurate to consider ourselves not as individuals, but as walking ecosystems, containing multitudes within a single skin. Yet the mechanism by which this astounding reality persists in our collective consciousness is rooted in the simple fact that our microscopic companions are entirely invisible to our unaided senses. And for centuries, we operated under the assumption that bacteria were nothing more than disease-causing pathogens to be eliminated, rather than recognizing them as essential partners in the grand choreography of metabolism, immune function, and neurological health. Deep beneath the surface of the Earth, in environments so hostile that life should not exist, scientists have discovered organisms thriving in conditions that would instantly annihilate almost every living thing we know. These creatures, called extremophiles, inhabit boiling hot springs where temperatures reach 300 degrees Fahrenheit, survive in the crushing darkness of deep ocean trenches where pressures would collapse human bodies instantly, persist in salt lakes so concentrated with minerals that nothing else can survive, and even endure the intense radiation of nuclear reactor cooling pools where the very fabric of their DNA is constantly bombarded by lethal energy. These microorganisms have fundamentally challenged our understanding of what life requires to exist, because they demonstrate that the narrow band of conditions we assumed were necessary for biology to flourish are merely the circumstances we happen to evolve within, not prerequisites for life itself. The mechanism behind extremophile survival involves evolutionary adaptations so remarkable that they seem to mock the limits we thought were absolute, including proteins that maintain their structure at temperatures that would denature normal enzymes, cell membranes built with lipids that remain fluid in boiling water, and DNA repair systems so efficient they can reconstruct genetic material damaged by radiation hundreds of times faster than normal cellular processes. Yet despite these discoveries transforming our biological understanding over the past 5 decades, the fundamental implications have been almost quietly normalized into contemporary science, absorbed into textbooks and lectures without the deep philosophical disruption they should inspire. We continue to search for life elsewhere in the universe by looking for water and moderate temperatures, for Earth-like conditions, yet extremophiles suggest that life might exist in the sulfuric clouds of Venus, in the methane lakes of Titan, or in the ice-encased oceans of distant moons, thriving in places we would have dismissed as absolutely sterile. Imagine a creature so impossibly small that you would need a microscope to see it, yet so fundamentally resilient that it could survive conditions that would obliterate nearly every other form of life on Earth, and this is precisely what tardigrades represent in the natural world. These microscopic animals, often called water bears or moss piglets, measure less than a millimeter in length and possess 8 stubby legs that give them an almost cartoonish appearance when magnified, yet their biological capabilities reveal something far more profound about the nature of life itself. Tardigrades exist in a state of cryptobiosis, a form of metabolic suspension so complete that they can survive extreme temperatures ranging from near absolute zero to over 300 degrees Fahrenheit. They can endure radiation doses thousands of times higher than what would kill a human being. They can survive in the vacuum of space with no protection whatsoever, and they can remain in this suspended state for decades without food or water. The mechanism behind this extraordinary survival capacity involves the replacement of water within their cells with a sugar-like substance called trehalose, which prevents ice crystal formation during freezing and protects cellular structures from damage, while their ability to enter cryptobiosis itself appears to be triggered by environmental stress signals that caused their metabolism to slow to an almost imperceptible level. What makes this discovery genuinely mind-shattering is that we have normalized the existence of these creatures despite their utter defiance of our understanding of biological limitations. We continue to study them as though their abilities represent some extreme outlier rather than a fundamental reimagining of what life is capable of achieving. And in doing so, we have perhaps failed to fully appreciate the profound implications that tardigrades hold for our understanding of life's resilience. Its adaptability and its potential to persist under circumstances that we would have confidently declared impossible before we actually observed them surviving. In the year 1900, sponge divers working near the Greek island of Antikythera discovered the scattered remains of an ancient Roman shipwreck resting on the seafloor. And among the corroded bronze artifacts and marble statuary they retrieved was a seemingly unremarkable lump of oxidized metal and wood that would eventually transform our understanding of ancient technological achievement. When researchers began carefully cleaning and examining this mysterious object over the following decades, they discovered it was not merely a decorative item or simple tool, but rather an extraordinarily sophisticated mechanical device containing at least 30 interlocking bronze gears of varying sizes, each tooth precisely cut and calibrated to mesh with its neighbors in an intricate dance of mechanical precision. The mechanism appeared to have been designed to track the movements of celestial bodies, predicting lunar phases, solar eclipses, and the positions of planets with remarkable accuracy, suggesting that someone in antiquity possessed not only advanced mathematical knowledge, but also the metalworking skill and engineering vision to translate abstract astronomical calculations into physical form. Yet what makes this discovery so profoundly mind-altering is the simple historical reality that nothing like this device appears again in the archaeological record for over 1,000 years, creating a haunting gap in our understanding of human technological progress, and raising the unsettling question of whether this represents a lost pinnacle of knowledge that somehow vanished from human civilization. The mechanism suggests that ancient scholars understood mathematics, astronomy, and mechanical engineering at a level that seems almost impossible given the tools and theoretical frameworks available during the Hellenistic period. Yet there is no documented tradition explaining how this knowledge was accumulated, transmitted, or preserved. In the rolling hills of southeastern Turkey, near the Syrian border, archaeologists in 1994 stumbled upon a site that would fundamentally reshape our understanding of human civilization and the development of complex society. Göbekli Tepe, whose name means belly hill in Turkish, represents a massive stone structure dating back to approximately 9,500 BCE, making it thousands of years older than the Egyptian pyramids and predating even the earliest known agricultural settlements. The site consists of multiple circular or oval structures built from massive T-shaped limestone pillars, some weighing up to 16 tons, arranged in concentric rings and decorated with intricate carvings of foxes, boars, snakes, and scorpions, all suggesting a sophisticated artistic and spiritual understanding. What makes this discovery truly mind-shattering is that Göbekli Tepe challenges the fundamental assumptions we held about human progression, specifically the long-held belief that permanent settlements and monumental architecture could only emerge after the development of agriculture and domestication of animals, the supposed prerequisites for civilization itself. The psychological mechanism underlying this discovery's significance lies in how we had constructed a neat narrative of human development, a linear progression from hunter-gatherer to farmer to builder, each stage logically dependent upon the previous one, and Göbekli Tepe shatters that comfortable framework entirely. Here were pre-agricultural peoples, nomadic hunter-gatherers still dependent on wild game and foraged plants, yet capable of organizing hundreds or thousands of individuals to quarry, transport, and erect monuments of staggering scale and precision, suggesting that complex social organization, religious belief systems, and monumental ambition preceded farming by millennia. In 1802, a fragment of black granite measuring roughly 3 feet 7 inches tall and 2 feet 4 inches wide arrived at the British Museum in London, having been discovered just 2 years earlier during Napoleon's campaign in Egypt near the town of Rosetta, and this single stone tablet would become the key that unlocked an entire civilization's written language after nearly 2,000 years of silence and impenetrable mystery. The stone bore inscriptions in 3 distinct writing systems: ancient Egyptian hieroglyphics at the top, Demotic script in the middle, and ancient Greek at the bottom, which meant that scholars possessed a translation tool they had never before possessed, since educated people could still read ancient Greek, but had completely lost the ability to decipher the sacred hieroglyphic symbols that had dominated Egyptian culture for thousands of years. Thomas Young, a British polymath, and Jean-François Champollion, a brilliant French linguist, independently began comparing the texts, recognizing that the same content appeared in all three languages, and through painstaking analysis of names, phonetic patterns, and linguistic structures, they gradually cracked the code that had sealed off the Egyptian language from the modern world, ultimately proving that hieroglyphics was not purely symbolic, but contained phonetic elements that could be sounded out and understood. What makes this discovery psychologically profound is how it demonstrates humanity's capacity to lose knowledge entirely and then recover it through the most unlikely means. For an entire system of writing, and all the literature, history, and cultural memory contained within it had become completely inaccessible, locked behind symbols that appeared to be nothing more than elaborate pictures and decorative artistic flourishes. And yet the simple accident of having the same text written 3 times in 3 different scripts created the Rosetta Stone effect that allowed modern minds to reconstruct what ancient minds had created. Imagine standing in a remote desert canyon near the Dead Sea in 1947 when a Bedouin shepherd boy, searching for a lost goat, stumbles upon ancient clay jars hidden in a cave for nearly 2,000 years. And within those vessels rest fragments of parchment and papyrus that would fundamentally reshape our understanding of biblical history, religious texts, and the development of early Judaism and Christianity. These documents, known collectively as the Dead Sea Scrolls, comprise approximately 900 texts written in Hebrew, Aramaic, and Greek, dating from roughly the 3rd century before the Common Era to the 1st century after Christ, discovered across 11 caves in the Qumran region, and representing the oldest known biblical manuscripts in existence. The psychological mechanism at work here involves the human tendency to assume that ancient religious texts have remained essentially unchanged throughout history, passed down through countless generations with perfect fidelity. Yet the Dead Sea Scrolls revealed variations, alternative versions, and earlier textual traditions that challenged this comfortable assumption about the stability and uniformity of sacred scripture. These scrolls included biblical texts showing minor differences from later versions, non-canonical religious writings that never made it into the official biblical canon, community rules from what scholars believe was an ascetic Jewish sect, and apocalyptic literature revealing the diverse theological landscape of ancient Judaism during a period of profound upheaval and Roman occupation. In the Valley of the Kings, beneath the scorching Egyptian sands, there lay undisturbed for over 3,000 years a burial chamber that would transform our understanding of ancient civilizations and the fragility of human legacy. When British archaeologist Howard Carter first peered through a small opening into the tomb of the young pharaoh Tutankhamun on November 4, 1922, he encountered a space so perfectly preserved that it seemed frozen in time itself, containing over 5,000 artifacts arranged exactly as they had been placed by ancient priests more than 13 centuries before the birth of Christ. The tomb, designated KV-62 in the archaeological record, had escaped the plundering that claimed nearly every other royal burial site in the valley, surviving intact through millennia of tomb robbers, earthquakes, and the relentless erosion of time that normally obliterates all traces of human civilization. The psychological mechanism underlying the obsessive fascination with Tutankhamun's tomb stems from a fundamental human need to pierce the veil between our world and death itself, to glimpse the material reality of how the ancients confronted mortality and attempted to preserve themselves and their possessions for an imagined afterlife. The discovery offered an unprecedented window into the intimate details of pharaonic existence, revealing not monuments or inscriptions, but the actual objects a young king believed he would need in eternity, from golden furniture to delicate sandals to jars containing organs removed during mummification. Yet what persists most powerfully is not merely the historical significance, but the emotional resonance of encountering the remains of someone who died at approximately 18 years old, whose name had been deliberately erased from history, and whose brief existence was suddenly restored to vivid presence through archaeology. Deep within the limestone hills of southwestern France, in a region known as the Dordogne, there exists a hidden chamber that holds one of humanity's most profound artistic achievements. a series of paintings rendered onto ancient stone walls approximately 17,000 years ago during the Upper Paleolithic period, created by people whose names we will never know and whose intentions we can only interpret through the faint impressions they left behind in pigment and ochre. The Lascaux Cave, discovered accidentally by four teenage boys in 1940 during the Second World War, contains hundreds of images depicting horses, cattle, deer, and mysterious geometric symbols rendered with remarkable sophistication and anatomical accuracy, suggesting that our ancestors possessed not merely the technical skill to create representational art, but also the conceptual capacity to imagine, plan, and execute artistic visions of surprising complexity and emotional resonance. The paintings were created using pigments derived from natural minerals like manganese dioxide for black, iron oxide for red and yellow, and charcoal, applied with remarkable consistency across the vast stone surfaces, indicating deliberate technique rather than random marking, revealing an intentionality and purposefulness that fundamentally challenges our understanding of prehistoric human consciousness. What makes these paintings so psychologically disorienting is that they represent the emergence of symbolic thinking, the capacity to transform physical materials into representations of absent things, to create meaning through the act of artistic creation, and to contemplate concepts like hunting, spirituality, and aesthetic expression in ways that seem to bridge the gap between our modern consciousness and a world separated from us by nearly 20 millennia of human development. In the year 79 of the Common Era, the Roman city of Pompeii experienced a moment of catastrophic violence that would paradoxically preserve it in perfect detail for nearly 2,000 years. And what makes this discovery so profoundly mind-shattering is not merely the volcanic eruption itself, but rather what the ash and pumice left behind, a complete three-dimensional photograph of human life frozen at its most ordinary and most desperate simultaneously. When Mount Vesuvius erupted with the force of multiple atomic bombs, it ejected superheated gas, ash, and rock across the landscape at velocities exceeding 100 miles per hour, and this pyroclastic flow reached Pompeii in minutes, killing inhabitants so rapidly that their bodies were instantly encased in volcanic material. And as the ash hardened around them, it formed perfect molds of their final moments, capturing not just their physical forms but the expressions on their faces and the positions of their limbs as they attempted to shield themselves or reach toward loved ones. The psychological mechanism that makes Pompeii so deeply unsettling operates on our fundamental understanding of time and preservation, because we are confronted with evidence that ordinary people, bakers with bread still in their ovens, people making love, children sleeping, merchants conducting business, were simply going about their lives when eternity interrupted them without warning or mercy, and this randomness of fate, this arbitrary moment when normalcy transformed into oblivion, strikes at something primal within our consciousness about mortality and the fragility of everything we consider permanent. Perched high in the Andes Mountains of Peru, approximately 2,400 meters above sea level, there exists a sprawling citadel of stone structures so precisely engineered and artfully arranged that its very existence seems to defy the logical constraints of 15th-century construction. Machu Picchu, known as the Lost City of the Incas, consists of nearly 200 buildings constructed without the use of mortar, yet fitted together so tightly that a knife blade cannot pass between the stones, even after more than 5 centuries of exposure to mountain weather, earthquakes, and erosion. The Inca civilization, which possessed no wheeled vehicles, no iron tools, and no written language comparable to Old World systems, somehow managed to quarry massive granite blocks, transport them up nearly vertical mountainsides, and arrange them with such geometric precision that they remain structurally sound to this day. The mechanisms behind such achievement likely involved the application of sophisticated understanding of mathematics, astronomy, hydrology, and material science, combined with extraordinary organizational capabilities and an enormous mobilization of human labor over extended periods. What makes Machu Picchu particularly remarkable, however, is that despite modern archaeology and engineering analysis revealing these logical explanations for its construction, the site continues to occupy a space in human consciousness somewhere between the empirically understood and the mysteriously inexplicable. Contemporary society has normalized this disconnect, presenting Machu Picchu simultaneously as both a solved historical puzzle with documented engineering principles and as an enduring enigma wrapped in romantic notions of lost civilizations and forgotten wisdom. We continue to marvel at the site not because its existence violates physical law, but because the gap between what we know was done and how we imagine it could have been accomplished remains psychologically vast and deeply compelling. For nearly 3,000 years, the city of Troy existed primarily in the realm of legend, a place that ancient Greeks believed had been besieged during the Trojan War, a conflict so monumental that it inspired Homer's epic poems and became foundational to Western civilization's understanding of itself. Archaeologists and scholars spent centuries treating Troy as mythological fiction, a narrative invented to explain the origins of Greek culture and heroic ideals, dismissed as the product of imaginative storytelling rather than historical fact. Yet in the 1870s, a German archaeologist named Heinrich Schliemann became obsessed with proving that Troy was real, that beneath the layers of soil in northwestern Turkey lay the actual ruins of this legendary city, and his determination led him to excavate the site near the village of Hisarlik, where ancient writers had suggested Troy once stood. What Schliemann discovered astonished the academic world. Not one city, but multiple cities built atop one another across thousands of years, evidence of widespread destruction from fire and conflict, and artifacts that seemed to correspond with the timeframe of the supposed Trojan War, suggesting that Homer's account, however embellished and mythologized, had been grounded in actual historical events. The mechanism behind Troy's persistence in human consciousness operates on a fundamental level of how we construct collective identity and meaning, wherein stories passed down through generations acquire a weight of emotional and cultural significance that can obscure the boundary between fact and invention, making the narrative feel true even when its literal historical accuracy remains uncertain. The remarkable aspect is that even though scholars still debate which destruction layer at Troy corresponds to the Homeric War, even though the actual historical conflict may have been far less dramatic than the epic suggests, the discovery that Troy existed at all vindicated the power of ancient storytelling and demonstrated that legends often contain kernels of real events transformed and elaborated through centuries of retelling. In 1974, in the Afar Depression of Ethiopia, a team of paleontologists led by Donald Johanson made a discovery that would fundamentally reshape our understanding of human origins and force us to confront the reality that our species did not emerge suddenly or uniquely, but rather evolved gradually from creatures that walked on two legs while possessing brains barely larger than modern chimpanzees, and this particular specimen. Female hominid that lived approximately 3.2 million years ago was nicknamed Lucy after the Beatles' song that played repeatedly in camp following the excavation, and her skeleton, though incomplete at roughly 40% preserved, revealed something extraordinary about the nature of bipedalism and its relationship to our evolutionary trajectory, something that challenged the prevailing assumption that large brains and tool use came first, that these were the prerequisites for upright walking. When in fact Lucy demonstrated that our ancestors had perfected the art of walking on two legs long before their cognitive abilities expanded to anything resembling modern human intelligence. The psychological mechanism underlying our fascination with Lucy relates to our deep human need to locate ourselves within the vast timeline of life on Earth, to find the concrete evidence that bridges the seemingly unbridgeable gap between ourselves and other animals. And Lucy provided exactly that, a tangible connection, a skeleton we could measure and analyze and photograph, something that made the abstract concept of evolution suddenly real and undeniable, and this need for proof. For visible evidence of our origins speaks to something fundamental about how humans process information about themselves, how we require physical manifestation of ideas before we truly internalize them. Deep within the Rising Star cave system in South Africa, beneath layers of limestone and darkness that had remained undisturbed for nearly 3 million years, archaeologists discovered something that would fundamentally challenge our understanding of human evolution and the very concept of what it means to be human. In 2015, an international team led by paleoanthropologist Lee Berger announced the discovery of Homo Naledi, a species of early human ancestor that possessed such a peculiar combination of primitive and advanced characteristics that it seemed to defy the conventional linear progression we had always imagined our evolutionary history to follow. The skeletal remains of at least 15 individuals were found arranged deliberately in a chamber so deep and remote that reaching it required navigating through narrow passages and squeezing through openings barely wider than a human body, suggesting that these creatures, standing roughly 5 feet tall with brains about the size of an orange, had intentionally brought their dead to this sacred place for reasons we can only speculate about. What made Homo Naledi so profoundly perplexing was not merely the mosaic of primitive and modern features preserved in their bones, but the implication that a species with a brain smaller than modern humans and creatures that stood between our earliest ancestors and ourselves appeared to practice ritual burial and possibly possessed awareness of mortality itself. The discovery forced scientists to reconsider whether advanced cognition, symbolic thought, and ritualistic behavior were not the exclusive province of our own species or even our closest relatives, but rather capabilities that emerged gradually and independently across multiple branches of the hominin family tree, challenging the assumption that intelligence and self-awareness developed in a straightforward ascending hierarchy that inevitably led to us. Deep in the Denisova cave in the Altai Mountains of southern Siberia, archaeologists discovered something that fundamentally challenged everything we thought we knew about human evolution and our place in the world. In 2010, scientists extracted DNA from a small finger bone, no larger than a pinch of salt, that had been preserved in the frozen cave sediment for at least 40,000 years. And when they sequenced this ancient genetic material, they realized they were looking at an entirely unknown species of human ancestor that had never been documented before, never been named in the fossil record, and had essentially been erased from our collective memory of what it meant to be human. The Denisovans, as they came to be called, were not Neanderthals, and they were not Homo sapiens like us, but rather a sister species that had diverged from our common ancestor somewhere between 600,000 and 700,000 years ago, and they had lived and thrived across vast regions of Asia, from Siberia in the north to the Indonesian archipelago in the south, occupying a geographical and temporal space that we simply did not know existed. What makes this discovery so psychologically disorienting is that it forces us to confront the realization that our understanding of human history is fundamentally incomplete, that entire civilizations and species can vanish so completely that we have no skeletal evidence of them whatsoever, no cave paintings bearing their artistic vision, no tools we can definitively attribute to them, leaving us with almost nothing but their DNA lingering in the genomes of modern populations. Particularly in Southeast Asian and Oceanian peoples, where traces of Denisovan ancestry persist to this day. The Denisovans represent a ghost in our genetic machinery, a phantom ancestor whose existence we can prove through molecular biology, but whose daily lives, beliefs, and experiences remain almost entirely mysterious to us. For decades, scientists operated under the assumption that Neanderthals and modern humans were entirely separate species with no genetic overlap, existing as parallel branches of evolution that never truly intertwined. Yet in 2006, when researchers successfully sequenced the Neanderthal genome from preserved skeletal remains discovered in Croatian caves, they made a discovery so profound that it fundamentally rewrote our understanding of human prehistory and our own biological heritage. The genetic analysis revealed that between 1 and 4% of the DNA carried by non-African modern humans today originated directly from Neanderthal ancestors, meaning that our species had interbred with Neanderthals during the thousands of years when both populations coexisted in Europe and Western Asia, leaving an indelible mark on the genetic code of billions of people alive today. This revelation emerged from the careful extraction and analysis of mitochondrial DNA and nuclear DNA from Neanderthal bone samples, which allowed scientists to compare ancient sequences with the genomes of contemporary humans from various populations across the globe, demonstrating not merely a brief encounter between species, but rather sustained contact and reproduction over extended periods. The psychological mechanism underlying our initial resistance to this discovery stems from our deeply ingrained tendency to categorize ourselves as uniquely special and separate from all other hominid species, a perspective that has been reinforced through centuries of religious doctrine and anthropological frameworks that positioned humanity as fundamentally distinct from our evolutionary cousins. And therefore the notion that our ancestors had mated with a species we considered primitive and less advanced challenged our constructed narrative of human exceptionalism and forced us to confront a more complicated and interconnected past. For roughly 200,000 years, anatomically modern humans evolved exclusively on the African continent, developing the physical and cognitive characteristics that would eventually allow them to inhabit nearly every terrestrial ecosystem on Earth. And yet the journey outward from Africa represents one of the most profound discoveries about human origins that has fundamentally reshaped our understanding of where we come from and how we came to populate the world. Between 70 and 100,000 years ago, small groups of humans began migrating northward through the Sinai Peninsula and into the Levant, gradually spreading across Asia, Europe, Australia, and eventually the Americas, leaving behind genetic markers and archaeological evidence that trace back to specific populations and specific moments in deep prehistory. The mechanism behind this discovery emerged through the convergence of multiple scientific disciplines. Genetic analysis of mitochondrial DNA and Y chromosomes revealed that all living humans descend from common ancestors who lived in Africa. Archaeological excavations uncovered stone tools, burial sites, and evidence of early human settlement patterns that corroborated these genetic findings. And paleoclimatic studies showed that periods of reduced rainfall and shifting environmental conditions may have driven populations to seek new territories and resources. What makes this discovery psychologically remarkable is that for much of human history, and certainly throughout recorded civilization, humans have organized themselves around narratives of fundamental difference and separation, creating elaborate mythologies about distinct origins and separate creations tailored to different peoples. And yet the scientific evidence demonstrates unequivocally that every human being alive today, regardless of ancestry or appearance, shares a common origin point in Africa, and that all the apparent variations in human appearance and culture emerged relatively recently in evolutionary time as populations adapted to different environments and developed distinct languages and traditions. Consider for a moment the profound transformation that occurred roughly 10,000 years ago when human beings made a deliberate decision to stop following migrating animals and gathering wild plants, and instead began to deliberately plant seeds in the ground, wait for months, tend to those crops, and build permanent settlements around them. This shift from hunter-gatherer existence to agricultural civilization represents perhaps the most consequential discovery in human history. Yet it emerged not from any grand scientific insight or careful planning, but from accumulated observations and trial and error across generations. Early peoples in the Fertile Crescent, China, Mesoamerica, and other regions noticed that seeds they discarded near their camps would grow, that certain plants produced more food than hunting could provide, and that they could gradually influence which plants survived by replanting the seeds from the most desirable specimens. What makes agriculture so mind-shattering is not merely that it allowed humans to produce more food, but that it fundamentally restructured human society, cognition, and our relationship with time itself. The mechanism underlying agriculture's success operates on a principle of delayed gratification and faith in cyclical patterns that required an unprecedented psychological shift in human consciousness. Where hunter-gatherers could see immediate results from their efforts, farmers had to plant seeds and trust that 6 months later, after seasons of watering, weeding, and protecting crops from pests and diseases, they would receive a harvest. This required the development of long-term planning, abstract thinking about future outcomes, and the ability to work collectively toward goals that extended beyond immediate survival. Before the invention of writing, human knowledge existed only in the fragile medium of memory and oral tradition, passed from one person to another through spoken words that evaporated into the air as soon as they were uttered, vulnerable to forgetting, distortion, and the simple passage of time. Then, somewhere around 5,000 years ago in ancient Mesopotamia and Egypt, humans discovered something extraordinary: the ability to capture thoughts, not in the mind, but in permanent physical form, using marks on clay, papyrus, and stone that could preserve ideas indefinitely and transmit them across vast distances and centuries. This fundamental shift fundamentally altered what human consciousness could accomplish, allowing a single person's thoughts to reach millions of minds they would never meet, enabling the accumulation of knowledge across generations, and creating a bridge between the dead and the living through the permanence of the written word. What makes writing so conceptually remarkable is that it operates as an external memory system, externalizing the contents of the human mind into a physical substrate that the brain can reference and process, thereby freeing mental resources that were previously consumed by memorization and allowing human intelligence to build upon previous discoveries rather than starting from scratch with each generation. The written word does not merely record speech, but rather creates an entirely new form of thought itself, a slower, more deliberate mode of expression that allows for complexity, nuance, and the construction of arguments that would be impossible to maintain purely in spoken conversation, fundamentally changing not just how we communicate, but how we think. Imagine standing in the Mesopotamian desert around 5,000 years ago, watching as a potter shapes clay on a rotating disc. And in that moment, you are witnessing what might be the most consequential geometric innovation in human history, the wheel, yet this circular object seems so elementary, so utterly obvious in hindsight, that we often forget it represents a cognitive leap of extraordinary magnitude. The wheel did not exist in nature as a functional tool that humans could simply observe and replicate. No animal rolled itself forward on circular discs, no tree naturally spun on an axle, and for thousands of years before its invention, humans developed sophisticated civilizations with agriculture, architecture, and complex social systems without needing this device at all. What the wheel required was not merely the ability to see a circle, but the capacity to imagine that a circle could rotate around a central axis, that friction could be overcome through this rotation, and that this principle could be harnessed to transport objects across distance with dramatically reduced human effort. The psychological mechanism underlying the wheel's invention involves a form of geometric abstraction combined with mechanical reasoning, where early inventors had to decouple the idea of circular motion from natural phenomena and project it onto functional applications, transforming the wheel from a mere pottery tool into an instrument of transportation by pairing it with the axle concept. Consider the profound absurdity of nothing masquerading as something, a conceptual abstraction that changed the trajectory of human mathematics and thought forever. Before the invention of zero, civilizations counted, calculated, and conducted commerce through various systems that simply lacked a symbol for absence, a placeholder for emptiness that could hold mathematical meaning. The Romans used their cumbersome numerals without it, the Greeks dismissed it as philosophically incoherent, and ancient mathematicians worked around its absence through increasingly complex notational systems. Yet somewhere in the mathematical consciousness of Indian scholars around the 5th century, a revolutionary idea took hold, that nothing itself could be quantified, could be written down, could participate in calculations as a legitimate digit with genuine power. This wasn't merely a notational convenience, but a conceptual breakthrough that required overcoming fundamental intuitions about what numbers actually are. When you hold 3 apples, you grasp 3 objects, but when your hands are empty, what exactly are you holding? The psychological barrier to accepting zero stems from this essential confusion between a symbol and reality, between the absence of objects and the presence of a representation of that absence. Our brains evolved to track things in the world, to count resources, to enumerate threats and opportunities, and this evolutionary heritage makes the concept of a number representing nothing feel inherently counterintuitive and somehow fraudulent. Yet we have collectively normalized this profound oddity to such a complete degree that modern mathematics, science, physics, and technology would collapse instantly without it. Every digital device, every equation, every computational system relies entirely on zero's paradoxical existence. We use it constantly without the slightest recognition of the revolutionary strangeness embedded within it, treating the void as if it were always and obviously a legitimate mathematical entity, when in fact its acceptance required overturning centuries of skepticism and philosophical resistance. Imagine standing at the edge of a cliff, watching a stone fall toward the earth below, and you find yourself asking a question that seems almost impossibly simple yet profound. At any single instant, is the falling stone actually moving? This paradox haunted mathematicians for centuries because motion itself seemed to defy the very logic we use to describe it, requiring us to measure change across time. Yet at any frozen moment in time there is no change occurring at all. Calculus emerged as humanity's breakthrough answer to this fundamental puzzle, a mathematical language invented independently by Isaac Newton and Gottfried Wilhelm Leibniz in the late 17th century that finally allowed us to rigorously measure the immeasurable, to quantify instantaneous rates of change and accumulation across continuous systems that had previously resisted mathematical description. At its heart, calculus operates through the profound insight that any smooth curve, no matter how complex it appears, can be understood as an infinite collection of infinitesimally small straight-line segments. And by analyzing these microscopic linear pieces, we can unlock the behavior of the whole, finding derivatives to measure instantaneous velocity and acceleration, while integrals allow us to sum infinite quantities to determine areas, volumes, and accumulated quantities. The psychological mechanism underlying calculus's transformative power rests on its ability to bridge the discrete and continuous, to treat infinity not as an abstract philosophical concept, but as a manageable mathematical object that we can manipulate with precision and rigor. Yet despite its extraordinary utility in physics, engineering, economics, biology, and virtually every scientific discipline, calculus remains a subject that causes widespread anxiety and avoidance among students worldwide, suggesting that our intuition about rates of change and accumulation remains fundamentally alien to our minds, that we have normalized a tool so powerful and essential that we barely acknowledge how strange and counterintuitive its foundational premises actually are. Imagine standing in an ancient Greek marketplace where a mathematician named Pythagoras observed something peculiar about the relationship between the sides of right triangles, noticing that if you take any right triangle and construct squares upon each of its three sides, the area of the square built on the longest side will always equal the sum of the areas of the squares constructed on the two shorter sides. A relationship so consistent and universal that it applies whether the triangle is barely perceptible or enormous enough to span across landscapes. This geometric truth emerged not from complex calculations or abstract philosophical reasoning, but from the simple act of observing patterns in physical space itself, patterns that appear so naturally that ancient civilizations from Babylon to Egypt had likely recognized these relationships long before Pythagoras formulated them into mathematical language. Yet somehow this particular arrangement of numbers and shapes became forever associated with the Greek philosopher's name. The psychological mechanism behind why this theorem captivates human understanding lies in its elegant simplicity paired with its profound utility, demonstrating that despite the infinite complexity of the visible world, certain fundamental truths remain constant and predictable, accessible to anyone willing to observe and measure carefully, which creates a deeply satisfying sense of order in an otherwise chaotic universe. For over 2,000 years, mathematicians operated under a fundamental assumption about the nature of space itself, believing that the geometry described by Euclid in ancient Alexandria represented an absolute and unchangeable truth about reality, where parallel lines never meet, angles in a triangle always sum to exactly 180 degrees, and the shortest distance between 2 points is always a perfectly straight line. This seemed so self-evident, so intuitively obvious when looking at flat surfaces and ordinary distances, that questioning it felt almost absurd, like doubting whether the ground beneath your feet was solid. Yet in the 19th century, mathematicians including Carl Friedrich Gauss, Nikolai Lobachevsky, János Bolyai, and Georg Friedrich Bernhard Riemann began exploring what would happen if they deliberately violated Euclid's fifth postulate, the parallel postulate, allowing themselves to imagine worlds where the old rules simply did not apply. In these alternative geometries, they discovered that you could construct entirely consistent mathematical systems where parallel lines actually do converge, where triangles have angles summing to less than or greater than 180 degrees depending on the curvature of space, and where the concepts of distance and straightness become fluid and dependent on the underlying geometry of the space itself. What made this discovery so mind-shattering was the realization that Euclidean geometry was not a fundamental law of the universe, but merely one special case among infinite possibilities, a specific description that happened to approximate flat space at human scales. The psychological mechanism that allowed this breakthrough was the willingness to separate mathematical consistency from intuitive spatial experience, to recognize that mathematical truth could exist independent of whether it matched our everyday perceptions. In 1931, a young Austrian logician named Kurt Gödel published a proof that would fundamentally shatter the mathematical world's confidence in its own foundations, demonstrating that within any formal system of mathematics, there must exist true statements that cannot be proven using the rules of that system itself. Before Gödel's work, mathematicians had labored under the assumption that if a mathematical statement was true, it could theoretically be proven through logical deduction from a set of basic axioms, much like building a house where every brick must rest upon a solid foundation below it. The dream was elegant and comforting: establish a few fundamental truths, and from these truths, derive all other mathematical knowledge with absolute certainty. Gödel proved this dream impossible, showing that no consistent formal system could ever be both complete and free from contradiction, meaning that truth and provability are not the same thing. His incompleteness theorems revealed a peculiar paradox at the heart of logic itself, one constructed through a self-referential statement similar to the ancient liar's paradox, where a proposition essentially claims its own unprovability within the system. What makes this discovery psychologically striking is how it demonstrates that certainty has limits, that the very language we use to describe mathematics contains blind spots that cannot be illuminated from within that language alone. We have normalized this revelation by compartmentalizing it, accepting that mathematics remains extraordinarily useful and reliable even though it cannot achieve the absolute completeness that earlier generations desired. Mathematicians and scientists continue their work without hesitation, not because Gödel was wrong, but because we have learned to live with the paradox, understanding that limitation does not negate utility, and that the incompleteness of formal systems does not make mathematics any less powerful as a tool for understanding reality. Imagine standing before a circle, any circle, drawn in sand or etched into metal, and you measure its circumference with a string. Then divide that measurement by the circle's diameter, and what emerges is a number that begins 3.141592653589793233846, continuing infinitely without repetition or pattern, a mathematical constant that has haunted human consciousness for thousands of years. This is pi, the ratio that describes the fundamental relationship between a circle's perimeter and its width, a number so deeply woven into the fabric of geometry and physics that it appears everywhere we look, from the orbits of planets to the structure of DNA to the spirals of galaxies. The psychological mechanism underlying our fascination with pi stems from a profound human need to find order within the natural world, to discover universal principles that govern existence. Yet pi presents us with something paradoxical and deeply unsettling, a number that is simultaneously infinitely precise and completely irrational, defying the closure and certainty our minds crave. Throughout history, mathematicians became obsessed with calculating more and more digits of pi, treating each additional decimal place as a victory against the incomprehensibility of infinity itself. And this compulsion has only intensified with computers, which have now calculated trillions of digits in an endless pursuit that serves no practical purpose whatsoever. What persists despite its apparent meaninglessness is our collective normalization of this infinite mystery, our acceptance that the universe operates according to patterns we can measure but never fully understand, that there are answers we can approximate but never complete, and somehow we have learned to live comfortably with this fundamental limitation, building bridges and engineering spacecraft using formulas that depend on rounding an infinite number to a manageable decimal. Trusting that our approximations are sufficient, even though mathematically they are always incomplete. Consider the peculiar reality of prime numbers, those integers greater than 1 that can only be divided evenly by themselves and 1, a mathematical property so fundamental yet so bewilderingly elusive in its deeper patterns that mathematicians have spent millennia pursuing their secrets without ever fully understanding them. The discovery of primes emerged not as a single moment, but as a gradual recognition that certain numbers possessed this indivisible quality, a realization that ancient Greek mathematicians like Euclid formalized around 300 BCE when he proved that infinitely many primes must exist, establishing forever that we would never run out of these peculiar numbers no matter how far we counted. What makes prime numbers so psychologically arresting is not merely their existence, but rather the complete absence of any discernible pattern governing their distribution along the number line, a randomness so pronounced that they appear almost chaotic despite emerging from the most rigid and logical system imaginable, the counting numbers themselves. We have discovered enormous primes containing millions of digits, yet we cannot predict where the next prime will appear with certainty, cannot determine a formula that generates only primes, cannot comprehend why they seem scattered according to no rational rule whatsoever. The Riemann hypothesis, perhaps the most famous unsolved problem in mathematics, concerns itself entirely with understanding the distribution of primes, and despite over a century and a half of the brightest minds working on it, the fundamental mystery remains uncracked, suggesting that nature has hidden something profound within this simple concept. We have normalized this bewildering gap between understanding what primes are and understanding how they actually behave by treating the mystery as merely another unsolved problem, rather than confronting the more disturbing possibility that the deep structure of primes might reflect something fundamentally beyond our capacity to perceive. a limit not just to our current knowledge, but to comprehension itself. In the autumn of 1982, a metallurgist named Dan Shechtman was conducting a routine experiment at the National Bureau of Standards, examining the atomic structure of a rapidly cooled aluminum and manganese alloy through electron diffraction patterns, when he observed something that should not have existed according to the fundamental laws of crystallography that had governed materials science for centuries. The diffraction pattern displayed a tenfold rotational symmetry, a mathematical impossibility that violated the ancient crystallographic restriction theorem, which stated with absolute certainty that only twofold, threefold, fourfold, and sixfold symmetries could occur naturally in crystal structures due to the geometric constraints of how atoms could pack together in three-dimensional space. Shechtman documented his findings meticulously, yet when he shared his results with colleagues, one of the most respected crystallographers of the era reportedly told him to go back and read his textbook, dismissing the discovery as experimental error or artifact. Because the scientific community had operated for generations under the unshakable assumption that all crystalline materials must possess either perfect long-range order with repeating patterns or amorphous disorder with no order at all, with no middle ground existing between these two states. What Shechtman had actually discovered were quasicrystals, a fundamentally new category of matter that exhibited a kind of order that was neither fully periodic nor random, possessing long-range order without translational periodicity, meaning the atomic arrangement never repeated exactly but maintained mathematical patterns governed by the Fibonacci sequence and five-fold symmetries that appeared throughout nature in spiraling shells and flower petals, yet supposedly could never occur in solid matter. In 1985, chemists working in a laboratory at Rice University discovered something that would fundamentally alter our understanding of carbon and reshape how we think about molecular architecture. They were vaporizing graphite with a laser, creating a plasma of carbon atoms, and when these atoms cooled and recombined, they formed a completely unexpected structure. A molecule composed of exactly 60 carbon atoms arranged in a perfect sphere, resembling the geodesic domes designed by the visionary architect Richard Buckminster Fuller. They named this discovery Buckminster-Fullerene, soon shortened to buckyballs, and the revelation sent shockwaves through the scientific community because it represented an entirely new form of pure carbon, joining the previously known forms of diamond and graphite in an exclusive club of elemental structures. What made this discovery so extraordinary was not merely its unexpected existence, but the profound implications it held for chemistry itself. The buckyball demonstrated that carbon atoms could arrange themselves in ways that scientists had simply never imagined possible, creating a hollow sphere with remarkable geometric precision where the carbon atoms formed pentagons and hexagons in perfect alternating patterns, much like the panels of a soccer ball. The stability of this structure seemed almost impossible given what chemists thought they understood about chemical bonding and molecular formation, yet there it was, stable and reproducible and real. The discovery opened entirely new avenues of research into nanostructures and nanomaterials, leading to applications in medicine, electronics, and materials science that we are still exploring and developing decades later. Yet despite the revolutionary nature of buckyballs and their profound importance to modern chemistry and materials science, they remain largely unknown to the general public, existing in that strange category of genuinely transformative scientific discoveries that have somehow failed to capture the popular imagination. In the year 2004, at the University of Manchester, two physicists named Andrei Geim and Konstantin Novoselov were experimenting with graphite, the same material found in pencil lead, when they discovered something that would fundamentally alter our understanding of materials science and the nature of matter itself. Using a remarkably simple technique involving adhesive tape, they managed to isolate a single layer of carbon atoms arranged in a hexagonal lattice, creating a two-dimensional material so thin that it is essentially invisible to the naked eye, yet possessing properties so extraordinary that it reads almost like science fiction. This material, graphene, is only 1 atom thick, making it the thinnest substance ever created by human hands, and yet it is approximately 200 times stronger than steel while remaining flexible and nearly transparent. The psychological impact of this discovery stems from the profound cognitive dissonance it creates between our intuitive understanding of how materials should behave and the reality of what graphene actually does. We have been conditioned throughout our lives to associate thinness with fragility, to assume that something so impossibly delicate must be easily broken. Yet graphene shatters this expectation completely by being simultaneously stronger, lighter, more flexible, and more conductive than virtually any other material we have ever encountered. Beyond mere strength, graphene conducts electricity better than copper, conducts heat better than diamond, is completely transparent, and can be folded, stretched, and manipulated in ways that conventional materials simply cannot tolerate. The reason this discovery remains so perpetually astonishing, despite now being nearly 2 decades old, is that it represents a fundamental expansion of what we thought possible within the constraints of physics and chemistry. Imagine a darkened laboratory where physicists have arranged what appears to be the simplest possible experiment: a barrier with two narrow openings, a source of light or electrons behind it, and a detection screen ahead. When researchers fire particles through these two slits without observation, something profoundly strange occurs. The particles behave as if they pass through both slits simultaneously, creating an interference pattern on the screen that suggests they interfered with themselves like waves in water. Yet the moment a detector is placed to observe which slit each particle actually passes through, the particles seem to sense this observation and immediately revert to behaving like ordinary particles, passing through only one slit or the other, and the interference pattern vanishes entirely. This phenomenon reveals something unsettling about the nature of reality itself, that the act of observation fundamentally changes what is being observed, not merely in a practical sense, but at the deepest quantum level. The mechanism underlying this behavior rests on the principle of quantum superposition, wherein particles exist in a state of multiple possibilities simultaneously, until measurement collapses these possibilities into a single observed outcome, suggesting that observation itself plays an active role in determining physical reality rather than simply revealing a pre-existing state. What makes this discovery particularly mind-shattering is that it seems to violate our intuitive understanding of an objective universe independent of observers. Yet generations of physicists have accepted and normalized this counterintuitive truth, incorporating it into the very foundation of quantum mechanics, while rarely pausing to contemplate the philosophical implications that consciousness and measurement might be woven into the fabric of existence itself. On February 14, 1990, the Voyager 1 spacecraft, having completed its primary mission of exploring the outer planets and now hurtling toward the edge of our solar system at 38,000 miles per hour, turned its camera backward one final time and captured an image that would fundamentally alter humanity's perception of itself and our place in the cosmos. From a distance of 3.7 billion miles away, Earth appeared as nothing more than a single pixel of reflected sunlight, a minuscule sphere of pale blue suspended in a vast and indifferent darkness. So small that if you were to hold a grain of sand at arm's length, it would appear substantially larger than our entire world did in this photograph. The image showed no national borders, no evidence of the wars and conflicts that have defined human history, no visible signs of the cities and civilizations that contain billions of lives, hopes, dreams, and the full weight of human experience across millennia. Instead, it revealed only a fragile world, a subtle blue marble surrounded by the absolute vacuum of space, a single oasis of known life in an apparently infinite and mostly barren universe. What makes this discovery so psychologically profound is that it represents the crystallization of a paradigm shift that had been occurring since Copernicus first challenged the geocentric model in the 16th century, finally rendering impossible any remaining illusions of human cosmic significance or special placement in creation. The photograph serves as visual proof of what we had intellectually accepted but emotionally resisted: that humanity occupies not a throne at the center of creation, but rather an insignificant speck on a small rocky world orbiting an average star among hundreds of billions of stars, in a galaxy that itself is merely one among billions of galaxies. The physicist Carl Sagan, who championed this image and its implications, described Earth as a mote of dust suspended in a sunbeam, and in doing so articulated something that our minds know to be true, but that our consciousness continues to struggle to fully integrate.